coffee break that we will be having, I would like to call to the stage João Claro, Chairman of INESC TEC, to conduct the official opening of the event. Welcome to the stage.
Good afternoon, and all be very welcome to the INESC TEC Autumn Forum. Professor Rui Calçada, the Dean of the Faculty of Engineering of the University of Porto, one of the founding associates of INESC TEC, Professor Arlindo Oliveira, President of the INESC Group, our other founding associate, Professor Roque Brandão, Vice President of the School of Engineering of the Polytechnic of Porto, also a long-standing associate of INESC TEC, Professor Carlos Seródio, President of the School of Science and Technology of the University of Trás-os-Montes e Alto Douro, a valued and more recent associate institution, our distinguished keynote speakers and panel participants, Professor Pedro Guedes de Oliveira, the coordinator of the forum, Professor João Peças Lopes, Chair of the celebrations of INESC TEC's 40th anniversary, representatives of all our partners, public institutions, higher education institutions, research and innovation centers, companies, associations, organizations from multiple sectors, all our friends and guests, whose presence we appreciate deeply, and all the members of the INESC TEC community. Thank you for joining us this afternoon, and in a year that holds particular meaning for all of us at INESC TEC. We are celebrating our 40th anniversary, and at the same time marking the 10th anniversary of this initiative, our Autumn Forum. The forum was created a decade ago, emerging from a simple but important idea. As we saw the expanding impact of the technologies that we work with across the economy and society, we felt it would be very important to have a moment each year to step back, bring in voices from outside INESC TEC, and reflect together on issues of relevance for the public debate and for our own thinking at the intersection of our sciences and technologies and society. The idea originated with Pedro Guedes de Oliveira, and he has guided the forum with great care and dedication throughout this full decade. I would like to acknowledge his contribution as we begin this year's event and mark the 10th anniversary of the initiative. For us at INESC TEC, celebrating 40 years has naturally been bringing our past and our future into the same frame. The work that has allowed the Institute to grow and the possibilities we want to explore in the years ahead. Digital technologies in general and artificial intelligence in particular have long been central to our work at INESC TEC. They have developed far beyond what could have been anticipated in our earlier days, and they remain deeply at the core of our work today, in our science, our collaboration with industry, our contribution to public programs, and the training of new generations. Choosing AI as the theme of this year's forum continues that long engagement, seen now from a new point in our collective journey, as an institution reaching an important milestone, and as part of a society that is navigating a major technological transition. AI brings different kinds of questions into conversation with one another: scientific, technical, social, ethical, cultural. This requires opportunities for broader dialogues, in which all these perspectives have something meaningful to contribute and which are becoming increasingly relevant to the public debate. With the theme being human in the age of AI, our intention is to contribute to that broader dialogue, bringing together people who can help us deepen our understanding, broaden the conversation, and look to the future with initiative, curiosity, and responsibility. Our program will begin with 2 keynote talks. Marzia Fadai will open the forum by offering a global and human-centered perspective on the development of advanced AI systems. She will be followed by Gita Coutinhoc, who will reflect on the mathematical and conceptual foundations that can help us understand and guide the next generation of AI. After the keynotes, we will host a roundtable with José Carlos Príncipe, Mário Boto Ferreira, Mário Figueiredo, and Sofia Miguens, moderated by Arlindo Oliveira and Rodrigo Pratas. The panel will bring the insights from these initial keynotes into dialogue with the questions that arise when these systems enter real contexts. We will conclude with the intervention of the Minister for Education, Science and Innovation, Professor Fernando Alexandre, whom we have the great pleasure of welcoming this afternoon and who will join us soon. AI is advancing in varied ways across the world, in research labs, companies, public services, and within cultural and educational settings. Some of this progress comes from collaboration, some from competition, and much of it reflects the contexts of each country or sector. In a landscape this diverse, our contribution does not have to be matching every development elsewhere. It must, above all, be meaningful and connected to our societal needs and aspirations. In such a landscape, moments like these are helpful. They allow us to listen to others, compare experiences, and understand where we can make a constructive difference. The future of AI will depend greatly on frontier breakthroughs, for sure, but these moments also highlight the importance of the steady and thoughtful way organizations apply and interpret these technologies in real-world contexts. Before closing, I would like to take a moment to recognize our colleagues at INESC TEC who have prepared this year's forum. Through Pedro Guedes de Oliveira, the forum coordinator, and João Peças Lopes, the chair of our anniversary celebrations, I want to thank all those who have dedicated much and the best of their efforts to bringing this year's edition into life. From the big ideas to all the little details, from what everyone is seeing this afternoon to the equally important work that always happens quietly in the background. Anniversaries remind us that organizations are living projects that grow by learning, adapting, and staying open to new realities. Few realities today are evolving as quickly or asking for as much reflection and responsibility as AI. So I would like to conclude with an anniversary-infused simple hope for this year's forum, that this shared afternoon may help all of us deepen our sense of what AI can make possible, that it may offer perspectives that we have not thought of exploring, questions that push our thinking, and perhaps a renewed confidence in the role that each of us can play, personally and within our organizations, in contributing to a thoughtful and responsible future for AI. Thank you for being here, and I wish us all an excellent forum.
Already know what we are going to do this afternoon. It is time to just give you a few more information about our first keynote speaker of the day, Marzia Fadea. She's the head of Cohere Labs, dedicated to working at the frontier of artificial intelligence progress with the goal of solving cutting-edge scientific problems. Her presentation is entitled Building Human-Centric Models from Global Voices. Now, please welcome live over the internet, Marzia Fadea.
Hi, everyone. Can you hear me? I don't see you. I hope you can hear me. I'm really sad that I cannot be there. I had a last-minute back injury and couldn't travel, and I'm sorry that I'm missing this great event in person, but very happy that can present virtually, and hopefully we can have a good discussion. I'm Marzia. I'm the head of Cohere Labs based in Amsterdam. My background, my PhD is on machine translation. I have been working with language models for many, many years before the current technology of large language models. And in my work at Cohere Labs, we build this technology. So we do research on what really makes AI work for human beings. And a big part of our focus is building this technology in a multilingual way. So really very well connected to the theme of this institute and this forum about how studying being human in the age of AI. And I want to talk to you today about how we can involve humans all over the world in creation of this technology and why we should do that. Maybe from some points from technical perspective, but also in general, how it can only benefit us as a society in the end. Right, so Cohere Lab, we are a very small research team. We started around 3 years ago, the research arm at Cohere, but we have been working nonstop on open questions in the area of language models. And for the past 3 years, we have published many of our work, as well as releasing our models open weight. In particular, a family of models that I want to talk more about, the AYA models, which are one of the first multilingual language models that we created 3 years ago, and we continue to contribute to this family. We also have a really large community of researchers around the world, and we are dedicated to this open science initiative of connecting and collaborating. And we think that communities and people globally should be involved in creation and research of this technology. Our open science community right now has more than 4,000 people around from around 150 countries around the world. And they are people from very different backgrounds. They can be like high school people to research engineers and machine learning engineers to professors at different universities. And with this particular community was one thing that we started noticing 3 years ago, that how people around the world are really using this technology, but it's not really built for them, and how we can make a difference about that. But before I go into what we did, I want to briefly talk about why we should really care about bringing this technology more globally to people everywhere. And I don't think anyone needs convincing that as more and more this technology is becoming part of what we do and how we do across different jobs, across different domains. And it's really now getting more and more embedded into different systems. And how, if it's just an English-centric model and technology, this will really isolate a big part of the world who might not really get the benefits of this technology at its best. So when we talk about involving people who speak different languages in creation of this technology, there's the question of access, the reason that you want for users around the world to use this technology. But there's also the question of the technology itself, what we are building and how we are building that. So, for instance, the more we focus on particular set of languages in creation of these models, the less it's clear the impact of that model in different languages. In this particular work, for instance, we looked at how models can be robust to harmful generations. So as you know, during the training pipeline of language models, you can have different safeguards, and whether it's from how you train and optimize the models to how the data that you use for them, to have a safe model so that you can actually deploy that in places that might be sensitive. But when you evaluate these models on different languages, you can see very clearly that there are some languages that are really, the models are generating much more harmful contents there than the others. And the main reason is that because during training, the focus was not the languages that are on the lower resource side of the spectrum. And why it matters is that when we only limit the training of the models to a small set of languages, we might think that we are only focusing on the quality of the model for those languages. But because of the backdoor opportunities that we are leaving open in more low resource languages, we are also introducing harm in the high resource languages. In this particular paper, for instance, they saw that if we try to jailbreak models, force the models to generate harmful content by translating harmful prompts to some of these languages, you see here like Ukrainian, Bengali, Italian, Hindi, the model is more or less robust, so only a relatively small portion of the attacks are bypassing the safeguards. But when we do the same translations to more low resource languages, more than half of the attacks are successful. And these are attacks that are translated back to English. So it's not just the people who speak, for instance, the Zulu language, who are seeing these harmful generations. So really this, if we spend little attention to a large number of languages, when we develop this technology, we are opening ourselves to risk for users in all languages for this model. And representation in data is a big part of that. So how for each of the languages that you want to represent, and essentially the community of people and human beings who speak that language you want to represent in the model, they should be first and foremost be data available to represent them. So really, the more that we aim to generalize over people, we really are aiming to include more and more in our data set. And when we talk about data, it's also what it looks like is important. So there is the linguistic aspect of including samples that are in a particular language, but there's also the particular point of view, the cultural nuances of each language and each community. So samples in the data that actually capture that is really important to have when we build this technology. And when we look at the current state of the open data, let's say the websites that are the main and the first source of training these models, they are predominantly English websites and data sets. And here already from beginning of training these models, we are introducing this inequality and imbalance of training mostly on English, but really wanting and aiming to capture cultural nuances in languages from all over the world. And there is also more nuances than just having English data and just translating English data. I wanted to highlight one of our work here where we looked at how the types of harmful generations, so stereotypes and essentially sentences and examples that are offensive and not really a good way of communication. There are some examples that are very global. So like if you're from anywhere in the world, you understand how this can be offensive. But then there are also examples that what we call that local types of harm. So really the types of stereotypes and offensive and harmful generations that are very specific to that particular language or region or community. And these are also very important to capture in your data, and how people around the world, we should be thinking about how to capture that. So I hope at this point, no one needs convincing that it's important to work on models that are truly multilingual and really care about representation of different languages in this technology. So for the second part of this talk, I want to go a little bit more in depth in our AYA initiative and what we have been doing in the last 3 years as part of our research on building this family of models, 5 models in total with a large number of data sets also released openly with the help of independent researchers from around the world in our community. And it was a truly global event. So we actually started this 3 years ago at a time that right now it's a little bit different. Right now, a lot of models are also working on multilingual problems, and there are a lot of really nice, strong models like Gemma, Quen, and then there are also like EuroLLM, Arabic LLM, like these different language models that focus on non-English languages. At that time, that was not really the case. And we set out with people from around the world in our open science community to first create a data set that represents these types of questions and prompts that people around the world ask these models. And we released that as AYA dataset paper. And we also released the dataset with the paper. And then the first AYA model was a model covering 101 languages trained on this dataset. Then last year, we released the second version of this model, focusing on 23 languages, but making them much stronger on this focused list of languages. And then a few months after that, we released AYA Expanse, which was truly a breakthrough in multilingual models at the time. And it was a combination of a few of our research works, putting the findings from all of them in one release and one model. If you are interested about the details of the work, you can check out the papers as they're all published openly. And then early this year, we also released the Vision version of this model. So AYA Vision is a multilingual, multimodal model that you can check them out. But how we did that and how really the role of human beings around the world in creation of this technology is what I want to talk to you about next. And like I said, the first step was to create this data set. The AYA data set and AYA collection, and we separate them because one is fully human annotated AYA data set, and then AYA collection is was created with a mixture of automatic processes like translation and templating existing data sets, and then manual quality checking of the final results. So this ended up, both of these data sets ended up being the largest multilingual instruction data sets still actually to date that are used in many trainings of language models still today as well. And we released them with open license for anyone to use. And it looks something like this. So when we look at the distribution of contributors and how much they, the percentage of the data that they contributed, most of the data comes from people from Asia, so languages, Asian languages, essentially. A large part of the data set also comes from Africa, and then we also have representation for Europe. And this is significant because a lot of low resource languages are actually African languages, and many of them are also Asian languages. And when we are generating, for instance, synthetic data to train these models for a lot of high resource languages, we can get away with using automatic process. But it's very important to have humans in the loop when we are collecting, annotating, and releasing samples and data for more mid-resource and low-resource languages. And I really like this plot, and I want to highlight it every time that I give a talk because it's a really nice representation of how the data on the web right now is not really representative of the world, and how in these global efforts of data annotation, we can actually remedy for that. So here, for instance, you see that the green dots, the line that you see, they are the size of the number of Wikipedia articles per language. So as we go from English to more low resource languages, the number of Wikipedia articles go down. And that we use as a proxy of representation of a language on the web. And then the blue bars are the size of the samples we collected in the AYA project for each of these languages. It's uneven because it really depends on individual contributors and how many there are and how many they contribute, but it is a more balanced representation of at least a good, and this is definitely not the full list of languages in the world, but at least a good balance for the top 100 languages in the world in terms of resources. And then we use this data set in building models, so combining them with also existing data sets. And I don't want to get too much into the details of this, but I do want to highlight here how really the quality of the data has an impact on the quality of the model that you have in the end. So this is a nice, and how we evaluate them actually, more importantly. So this is a nice plot to show that we can, we evaluate on different tasks when we create this model. So tasks can be discriminative. They can be generative tasks, so more generation of natural sentences rather than just like one-word answers. And then they can also be win rates, so against a strong model, how like preference of how the model is doing, which is doing better. And we see that depending on the task, the data that we use can have a different impact on the task. So for instance, if we are evaluating on translation, so Flores is a task on machine translation, we see that actually including translated data has the biggest jump there. But then is this a good indicator of the quality of the model, or does the model actually feels more like it doesn't feel natural, it feels like it's translated? And we see that that can be the case. So like, for instance, in a more open-ended generation task, really translated data can help, but really human annotation can also have the biggest jump to the improvements and the gains that we can see. So really thinking about when we build this technology, the balance between what is our end goal, what we want to evaluate these models, what we want them to be good at, and then depending on that, how we use our human resources and annotators and data curation pipeline to help that goal. That's really the main takeaway here. And depending on that, there should be a synergy here. I briefly touched evaluation. I do want to go a little bit deeper into also when we talk about getting humans involved globally in this technology, how does that reflect in more inclusive evaluation and in our in multilingual evaluation? So the main problem, one of the main problems in current benchmarks and how we evaluate is that many of them are still very much English and US-centric, whether it's about the language itself or about the types of questions that are in these evals. So for instance, the MMLU dataset, which is a really well-known and globally used benchmark, there are a lot of questions there on, I do have the slide for that. So there are a lot of questions in this evaluation on specific topics that are about, that you have to be you have to know regional knowledge from US to be able to answer. Sometimes it's about geography, about politics, history. We actually did a study. We looked at each question in this benchmark to see how much agreement and disagreement you have between annotators based on essentially how global versus how US-centric the questions are. And we found that for many STEM topics, you do need a high level of agreement between annotators, which means that you don't need specific regional or like more nuance, or whether it's like regional or it's just ambiguous knowledge to answer that. But then for a lot of topics that are kind of in the category of social topics, we see that that's not the case. So here, for instance, you see, so on the other side of the spectrum, you have examples like mathematics, computer science, algebra, so topics that are very much universal. And then on this side, we have topics like philosophy, professional law, high school, world history. So really topics that most likely depending on where you're from, what history you know, you might disagree about the answers. And that's the main problem with evaluation these days, that it's either only English-centric, or even if we translate them, then the topics themselves are still very much English-centric. So this study was part of this paper that you can check out for more details, that we released on making the MMLU benchmark more global. So adding these annotations to differentiate between questions that are culturally sensitive versus culturally agnostic. But this is still working with questions that are from the US background. In one other work last year, we worked with the Swiss AI initiative on creating a benchmark that is truly inclusive. For this particular one, we worked with people from around the world, covering 44 languages, and collected exam questions from those languages, from those regions. So instead of questions about geography of US, then you have individual questions about geography in Portugal, in China, in everywhere around the world. And the topics that we included were also topics that are more culturally nuanced. So for instance, art, humanities, social science, health education, business and commerce, professional laws. And we still also included STEM topic there, but a small portion of that. So most of this benchmark actually captures individual cultural nuances for each of these languages. And this was another huge data collection effort that I, again, want to highlight. When we are talking about the age of AI and where we are with this technology, getting people from around the world involved in creation of this technology is really important. And it's not really a glamorous task. There's a lot of challenges there as well. But it is really important to have people so that their language, their point of view is represented in this case, in the evaluation, but also in how we create these models. As part of this work, we also found that it was very interesting that for many languages, we still saw like a difference in terms of performance of the really top models on more global versus regional questions, but the differences were small, so they were not that actually hugely different. For some languages, they're actually really large, for instance, for Azerbaijani. But for many languages, the models are performing on par on regional and global knowledge. What this tells us is that also models are developing as these benchmarks are creating to measure this, to capture this. But this is really important to have to make sure that this part of really like individual cultural nuances of each language is also represented in this technology. So to summarize the lessons we learned by building the IA initiative for the past 3 years and embarking on a bunch of working with a global community to create benchmarks and evaluations for this technology, I think it's really important that everyone on the technical side, but also on a more human side, they should take into account. And one is that a lot of times in this technology, we are impressed with what they do. We don't value the human involvement and human annotation part as much in the beginning, because when we get to the end, the magic of what they do is really what we want to talk about the most. But I do want to emphasize how it's important to involve everyone in the beginning in creation of this, whether it's data sets, evaluations, red teaming and testing of these models that I really didn't get into. And there's a huge amount of value there. And the second one is that it's really important to have as much even representation for each language as possible. And there are two aspects to that. It helps to, especially if you don't have a language represented, and then you do, that's great for people who speak those languages. But there are also works that show how cross-lingual transfer can help making stronger models in the end. So really by capturing the diversity of the human intelligence, you actually make this technology much more stronger. And also at some point, it's really the global scale of involving people around the world can be very challenging and difficult. And when necessary, we can use proxies. We can carefully curate our data pipelines so that we can also rely on this technology to create data sets in a synthetic way. And really, in the end, the focus should be on what is our goal, what we want this technology to be good at, and really measure for that rather than some really unknown translated score that you don't really, that might not correlate with what you want to use this technology in the end in your particular use case. And when we think about really how to truly make this technology human-centric, in my mind, there is the question of involving humans from beginning. So whether it's the data curation to really the point of view of humans in evaluation, and making that not the secondary goal, but really the main goal, to make these technology culturally aware of the languages that they speak, and including this grounding into the training and into the learning pipeline. So not really having a second, like I said, like a secondary goal, but being part of the main goal of this creation of this technology. Right, and I do want to emphasize again, I do see working on multilingual problems and human-centric AI, not really something about just including diversity as a challenge, but it is really about capturing the intelligence of us human beings from around the world in this technology in the end. And with that, I'll stop here. Thank you so much, and I hope the talk being remote was not too far from connecting with you, and I look forward to your questions, I think, later today.
Thank you, Marzi, for your input. And from human-centric model to trustworthiness, we now move on to our second invited speaker of the afternoon, Gita Kutiniok from the Ludwig Maximilian University of Munich in Germany. Will talk about the future of AI and how reliable it can be. We welcome now Gita Kutiniok.
Yeah, thank you very much for the very nice introduction, and also thank you so very much for the invitation. It's really a great pleasure and honor for me to be here at this very special event and also in this amazing hall. I think we all know how tremendously important AI is these days, and I think everybody will agree by now that this is the key technology of the future. And so, if you see the motto being human in the age of AI, what we certainly require is that also AI obeys human values, in particular also our European values. And so the talk will be about how we can, where we stand right now and how we can ensure that for the future. So, let's see how this works. Yeah, so let me start at a very high level. I think we are all aware that we are at the beginning of the fourth industrial revolution by artificial intelligence. Yeah, so we have already lived through 3 of those. I mean, not everybody here present, but I mean, humanity has lived through 3 of yours. And I think everybody agrees that the previous 3 brought us a lot of good things. Yeah, so I think steam engine and so on was, I mean, very advanced, electric energy, also computer automation, and I strongly believe also the fourth industrial revolution will bring a lot of good for humanity in the end. But still, I mean, every of those industrial revolutions goes along with a radical change of the society, as will also the fourth. And we will see during the next 5-7 years a radical change of our society in its full breadth. And we see it already now. Yeah, so if you see, I mean, how your life is changing around you, think of the administration, think of mobility, agriculture, telecommunication, and then also by now, I mean, very sensitive areas are impacted, like, for instance, the legal system, journalism, education, and so on. And so I myself come from the area of sciences, and I think it's fair to say by now there's not one area of sciences which has not witnessed a paradigm change by AI at this point. Yeah, and so you see, I mean, many changes. I would like to just, I mean, also highlight what advantages this brings. I mean, one particular area which is, I think, important for also industry, also universities in general, which is administration. Yeah, I mean, also at LMU, we are now thinking about bringing AI more into administration. So what are the huge advantages, in particular now in this area? Yeah, so let's look at this as a use case. I mean, for instance, a lot of routine tasks can be supported by AI, looking through, I mean, tons of data, searching for, let's say, some strategies for financial strategies and so on. So all those routine tasks can be substituted or can be, let's say, supported. Also, there can be an error control. So for instance, if you write something, I mean, AI in the background can make suggestions what to improve, how to improve it, where maybe a mistake occurred, where some anomalies in the, let's say, financial strategy occurs. Then also communication in general. I mean, think of AI bots which answer requests, but also in general, I mean, communication, writing small articles, and so on can be supported. And last but not least, I mean, general decision-making, creativity can be supported by AI, but I think all of those show that in the end, I mean, right now, what we are at is that people are not replaced by AI, they are supported by AI. So AI is in a certain sense an augmentation of humans, of humanity, and help in particular, I mean, getting rid of, let's say, maybe some annoying tasks and also give us free time for more important tasks. But certainly, I mean, also the whole, let's say, work system will to a certain extent change which positions there are. Okay, so this is concerning administration. So the question is, I mean, this looks positive. Why do we actually need AI? Not only because it brings us, let's say, some advantages, but it is absolutely necessary. So let me argue about that. So, I mean, many countries, in particular in the Western world, are experiences a demographic change. So in the future, I mean, there will be not enough younger people, for instance, for caring for the elderly, and also doing tasks in general for society. So in that sense, AI is, to a certain extent, a necessity in that respect. Also, we, for instance, in Germany have a lack of IT experts. I think in general in Europe, it is the case, and also AI can replace this to a certain extent. And third, economic power. So right now, I mean, we are in a geopolitical situation that AI is absolutely necessary for bringing countries forward. So if you basically lose the AI race, this is a serious problem for the future. So also there, AI is necessary for the future. In addition, complex problems, climate change, think of also energy production and so on. All of those create such a huge amount of data that AI is necessary for solving many of these highly complex problems. And I mean, maybe as a fifth point, education. Also here, AI can make a huge difference and is already making a huge difference. So all of those are points why, to my mind, AI is also not only positive for the future, but also absolutely necessary to a certain extent. So I talked a lot about AI right now. What is it? And I would like to, in the beginning, I will go in a little more depth later on. In the beginning, just show you the three key directions of AI, or the three categories of AI. So one is predictive AI. So there, I mean, what happens is AI learns on large data sets, and it is then able to predict patterns, to detect relations in large data sets, and then make predictions, also classify data. So for instance, I mean, concerning financial strategies, what is the best strategy? What could we do next? Also in medicine, classifying, for instance, cancer or not. I mean, all of those are predictive AI tasks. And what is usually used for that is artificial neural networks. Applications are administration, medicine, trade, and so on and so on. The second large category, which I think by now everybody is familiar with, is generative AI. I'm sure everybody has used by now ChatGPT. So here, I mean, what generative AI basically does is therefore it's called generative, it generates new contents based on existing data. So the goal is, for instance, content generation, also creative applications, like for instance music, maybe you've seen that, and the examples are large language models, when we heard just an amazing talk about large language models. Also there are numerous applications. So these generative AI, maybe as I should also mention, because right now there's a lot of talk about basis models in Europe, so usually there's a basis model which is just in a very unstructured way trained on the entire internet, and then in the second step one can fine-train it on specific data sets from law, from medicine, and so on. And so right now I think there's also discussion to create these basis models in Europe. Last but not least, reinforcement learning. Yeah, so reinforcement learning, it learns by interaction with the environment through a certain reward system, and the goal is to maximize and optimize the strategy for the future. So one particular use case is AI agents, robotics, so their reinforcement learning is typically used. So these, I mean, are to a certain extent the three main categories which we have right now on artificial intelligence. So this all looks, I mean, extremely positive. So let me now ask, are there still challenges? Because again, I mean, the title is Being Human, so certainly we would like, again, I mean, that human values are obeyed, and so the question is, I mean, are we already there at present? So one, let's say, area where we still have some way to go is reliability. And so here you see a couple of examples on the slide. For instance, right now we still have problems with safety. There were accidents involving robots, and self-driving cars are nothing else than a robot. So you've seen that in the media, so safety is not at that level maybe as we want it to be. Security, there's always the possibility to hack into the systems. So there's another problem which there's still room for improvement. Privacy, these methods require these enormously large data sets, and privacy violations happen, unfortunately, daily worldwide. So in particular where data is scarce like health, and so the question is, can we develop models which use much less data, scarce data setting? And then problems with, I might say, responsibility. So many of these decisions are black box decisions. We don't really completely understand how decisions are reached, and also decisions can be biased. So in that sense, I think it's fair to say that one current major problem worldwide is that we are still not at that reliability level which we want to be, and one main approach to that, and so this is something I think which everybody can understand, is we need to understand these problems in their depths and then tackle them. And so what we go for, and I will say a few words, I mean certainly also in the second part of the talk, is we require a deep understanding also from a mathematical perspective. The second key, let's say, area where we also still have a lot of room for improvement is sustainability and energy efficiency. And so also let me show you a couple of figures there. You might have seen that if you're on Twitter and X, in the US there's a new hyperscaler and the nuclear power plants are planned right next to it. So you see these methods require an enormous amount of energy. You need to basically, if you plan such a large data center, compute center, you need to in particular also plan the power source at the same time. That is difficult, but I mean the situation is more serious than that. So this is from the decadal plan of the Semiconductor Research Corporation in the US. What you see here plotted in white is the world energy production, and I would like to show you now the energy which is just needed for communication, also communication between AI agents, and this looks like this. So you realize a serious problem because we cannot use more energy than the world produces. So this is the limit, I mean, which is absolute in a certain sense. Now you see here people use CPUs. So if we are a bit smarter, we use GPUs, we can lower this curve, and then if we use even new hardware, innovative hardware, and I will come back to that, I mean, again, in the second part of the talk, we can lower it further, and if we are even smarter than that, we also improve the software, we can lower it further even more. And also here, I mean, let's say a mathematical background plays a significant role. So I think it's fair to say that reliability and sustainability are still, I mean, two main points for AI where we need to make progress. So now, since again we talk about human values, and here I would like to also talk about European values, the question is, I mean, we are here in Europe, what are our European values? So now if you come to the European Commission, you see, I mean, so these are the guidelines for trustworthy AI, which were decided upon. AI should be lawfulness, it should obey ethical values, and it should also be robust, both from a technological and a societal standpoint. And if you go a bit deeper into the document, I mean, not like to boring you with all of that, so there are these 7 human values which AI should fulfill: human oversight, robustness, security, data governance, transparency, accuracy, then welfare and record keeping. And so the 2 we just talked about, robustness, so reliability, and also societal ecological welfare, these are 2 of those which require still, I mean, a bit of work. And also fairness, we know, I mean, there's still a bit of room for improvement. So I think AI is extremely helpful at present, but again, I mean, from a scientific viewpoint, we still have a way to go to make it really human-centered. And so I would like to now, in the second part of my talk a little about that. So in that sense, I mean, we need disruptive new ideas. We cannot continue the way we did before. To the left, I think this is clear. We need really new ideas, in particular also concerning energy sufficiency. And here I would like to take now a foundational approach, because then you can understand the problem in their depths and see how to tackle it. And so, I mean, the most basic, let's say, foundational approach you can take is a mathematical perspective. And here I would like to, in the beginning, immediately say, don't worry, there are not too many formulas, yeah, so everything is on a very high level. But still, I mean, I would like to show you, I mean, a bit what people are working on right now, what I'm working on right now, and where the journey goes for the future. So that we are all on the same level, let's just agree on what deep neural networks are. These are the workhorse for artificial intelligence. That's nothing new. It's actually a quite old idea. It was developed by McCulloch and Putz, and 1943. They wanted to introduce artificial intelligence, and well, I guess we humans, we believe we are intelligent, so what they did was they wanted to build a mathematical model for the human brain. And so the human brain consists of neurons which are interconnected. And so what you see here on the slide, the formula is the formula for an artificial neuron. So that's the mathematical model which they introduced for an artificial neuron. Very simple, but I mean, you can work with it. And then you connect everything and you get an artificial neural network. And don't look at the details. The only point here I want to make is that a deep neural network is a mathematical function, and in that sense, from my viewpoint as a mathematician in computer science, AI is to a certain extent mathematics, and we have the chance now by foundational approaches, by theoretical approaches, to really understand things in their depths, in particular concerning human values, and then, I mean, bring it forward and tackle it for the future. Okay, so what are our tasks? What do we need to do? So for that, I would like to just once go with you through how we apply actually deep neural networks in practice. So what do we do? Well, I mean, we have, let's say, our relation. Let's say we have images and we have labels. Yeah, typically you have cats and dogs, and then you have the labels. This is a cat, this is dog, but it can be much more complicated. Yeah, cancer, yes, no, and so on and so on. So mathematical terms, so we have a function, a function which maps our data to some, for instance, labels, and we have some samples of that. Then we need to decide which architecture to choose of the neural network, because now we want to use a neural network, which is a function, to approximate this original function. And here it already starts. Yeah? I mean, if you work in this area and you know that's a lot of trial and error, testing different architectures, it costs a lot of time, it costs a lot of money for industry, you have to choose how many layers, and so on and so on. Once you've decided that, you train, so that means you try to fit your data which you have, so the training data with your architecture, there are algorithms for doing that, and finally, once you have that, you check whether your neural network learned something reasonable, so that if you now expose it to unknown data, let's say to a new image, it gives the correct answer. Now, so that's generalization, that's the performance check. So this raises the following questions, I mean, from, let's say, a reliability, also mathematical standpoint. The first is expressivity. So which architecture do I choose? Do I choose a transformer? Do I choose a convolutional neural network? And so on and so on. Yeah, so here the idea is to develop general guidelines for a particular application setting. What is the best architecture which we can choose? Then comes the learning. Yeah, so the learning algorithm. The learning algorithm, well, I mean, it does what it does, but you would like to know when it succeeded, how good it succeeded, and so on. Yeah, so here the idea is if you develop a mathematical theoretical foundation, what is the best training algorithm? Then generalization, can you generalize to unseen data? And, so these are performance guarantees. And last but not least, explainability, can you explain the results? Can you understand where the results come from? And so now I would like to just very quickly, I mean, delve into two of those topics, namely generalization and explainability. So generalization, so here the question is what happens if we have, let's say, our neural network, which we trained, can it generalizes. And so let me now go to the example of a graph neural network. So these are neural networks which act on graph data, and so you see a couple of examples here, fake news detection, chemistry, all of those are graphs. Yeah, and so they decide, for instance, whether this is a, let's say, suitable molecule for a particular task. Now, the question, this generalization question, is, let's say you have two graphs and you would like to know, so for instance, one, the right-hand side is in your training data set and the other is in the test data set, so which you would like to generalize towards, and you would like to know how bad you can do. And so here you have the situation that these graphs could be somehow alike, and so you can ask a sub-question whether Yeah, so if you have a graph in your training data set and the graph which you expose it to looks somehow similar, whether you can bound the error. And so there are many approaches in that direction, and so here this is what I would like to show you. For instance, we have error bounds for the generalization error in this setting. So in that sense, I mean, you have absolutely certainty if you now use these neural networks, how good they are if you expose them to unknown data. And that gives you a lot of security and a lot of trustworthiness in that sense. And so, for instance, in Germany, I mean, the, let's say, Federal Agency for Telecommunication is using AI not at this point for critical infrastructure because these error bounds are not there at the, let's say, large level which we require. So a lot of research goes in that direction. The second I would like to also mention is explainability. So explainability, so let me show you this slide. So what is explainability? In its easiest form, you have an image. So here you have the 3. The neural network says this is a 3. And then you want to know how it came to that decision. And so the explainability approaches produces these heat maps, which you see there in the middle of the talk, of the slide. And these red parts, this is where the network looked at. And that makes sense because these openings distinguish a 3 from an 8. Yeah, so looking at that makes sense. But then if you look at this image on the right-hand side with the horse, so there the neural network says this is a horse. But look what the explainability approach does. The neural network only looked at the name of the photographer. It didn't look at the horse at all. So what happened? Well, I mean, the training data was chosen in an unfortunate way. It had, all horses had this name of the photographer there. And so the network did the smartest thing, it just learned the name. And so therefore, you can find out when prompts occur. And so now you can ask, what is relevance precisely? What are optimal, let's say, such explainability approaches? Can we develop higher level approaches? Also, in the end, you would like to talk with an AI like you would with a human about a decision. And finally, what you would also like to have is you would like that the explainability approach is reliable itself, because if you want to use that, then for legal purposes, then, I mean, it better also be reliable itself. So let me, just very briefly talk about one approach which we developed, which is based on information theory. And so the idea here is basically you want to analyze, you see this image X from Alice, you would like to analyze if you only extract part of it and you obfuscate it, for instance, how much the decision changes. Because if this part which you extract is the relevant part which the network looked at, then the decision should not change. Yeah, and so you can make this, mathematically very precise. Maybe I should not go too much into the details here. And then you can derive basically, let's say a formula for this, for the task that you would like to have very few pixels which are relevant and the decision does not change much. And so we developed an approach, which is this RDE approach, which is based on a mathematical performance analysis. So let me show you some examples in that direction. So here, you see, for instance, an experiment where a neural network recognized a dog, and you see explanations of that, and you see ours on the right-hand side is tuned for sparsity, but in any case, it shows the network looked at these heads of the dog. Yeah, and then you can generalize this approach in different ways. You can obfuscate with not random pixels, but more, let's say, interesting pixels. You can also not just look at pixels, which are explanations, but you can take canonical parts of, let's say, pixels, which, for instance, this wavelet decomposition is. And then you can do things like this. So here, you, for instance, have a city map, these blue buildings, these red dots are cell phone users. The white blob in the middle is a cell tower, and the black and white background, this is what the network computed. This is how strong the signal is. But then, you see that in the middle you have this black area, which is an area of bad reception. And so here, this area of bad reception is where it should not be. Yeah, because here, I mean, you would basically have a good reception because you actually see the cell tower. And so then, I mean, you have this green square, and we would like to know why the network reached that decision in this green square. And so now you can ask how it came to that decision. And on the right-hand side, you actually see what the explainability approach did. And so the explainability approach said, well, I mean, this area of bad reception was done, and the network looked at, let's say, these buildings which you see there on the right-hand side, and also these red dots, which are cell phone users. And these cell phone users actually have bad reception. And so it makes sense to mark an area of bad reception there. And so what turned out later on was there was actually a building missing in this city map. So the network did something correct. So this area of bad reception made sense given the data which was there. But the data was faulty. So this you can understand using these explainability approaches. So it is said understanding seemingly wrong decisions that you can do. So explainability approaches gives you a lot of certainty. It basically reveals what the network has seen and reach a conclusion. You can also understand wrong decisions. And so I would also like to show you one example of that. This is actually a kind of funny example. So here the network in the first image decided this is a diaper, although it's a man with a dog. And in the second image, the network decided this is a screw. Yeah, although it's also obviously a man with a sweater. And now I would like to overlay this with the explanation, and then you can see what the network has seen to reach that wrong conclusion. Yeah, so I will put it on top, and then you will see why it reached the decision that the first is a diaper and the second is a screw. Yeah, and it looks like this. Yeah, and so the first image, this dog can be mistaken for a child, and then a diaper is not far off, and the sweater can be mistaken for a screw. So that way you can reveal why problems occur with neural network decisions, and then you can counteract, you can fine-train afterwards. And so, I mean, to conclude this part on explainability, I would also now like to show you one theoretical result just on the next slide, because one key point for me is always, as said, if you use explainability for trustworthiness or for ensuring, let's say, human values, you have to trust the explainability approach itself. It's not enough that it produces some nice, fancy pictures. And so we can extend this now, I mean, to also different types of systems. And what I would like to show you is this theoretical result. So what you see here is the phenomena which is a bit problematic for explainability approaches. On the left-hand side, you see the original image, cloak, yeah? And then you see different explanations. You see here cartoon X, and you see this pixel RDE. And for each of the three images, you see the structure of the edges. Now, what you would expect and what you would hope for is that if you look at the explanation does not invent any new edges. Yeah, so it should be consistent with the edges of the original image. But if you look very closely, you observe that this pixel RDE approach invented some new edges, which shouldn't be there. Huh? And so now, I mean, because this approach which we have, cartoon X, is based on mathematical underpinning, we can get a rigorous result. And I would just like to show it to you so that you get a feeling of what I mean. Yeah, so here, I mean, this result shows rigorously that the edge structure of this cartoon X is always a subset of the edge structure of the original image. Yeah? So you see it here in very fancy mathematical terms. Yeah, don't worry about the details. For those of you who are maybe closer to mathematics, let me say this is a result about the wavefront set, yeah, so of the original image subset which is the superset of the wavefront set of the explanation. Yeah, so this is what I mean by certainty, trustworthiness of explainability. So now we delved a little bit into two of those areas, which were generalization, and people sometimes call it the holy grail of neural network theory, because this is basically what you want. You would like to have guarantees for, if you now expose your AI to unknown data, you would like to know how good it does, how bad it can be, how large the error can be, which you make. And explainability is something where, you basically reveal why decisions are taken. I would now like to delve a little deeper. In a sense, to, as it says, the core of reliability and sustainability. So these were the two, let's say, areas where still challenges occur, and I would like to now, as said, delve a little deeper, and you will see in a moment what I mean by that. Because, the basis for everything, but we don't talk about it much, is the computing. Yeah, so we have a lot of fancy algorithms, we develop software, but we don't talk much about the computing. But we should. And I would like to argue why and where, basically, from my perspective, the future of AI computing is. So let's look at where we are right now. Computing is basically the heart of modern technology. We need it for everything. Also, generative AI could not live without massive computing. Also, medicine and so on could not live with massively distributed computing, and so on and so on. So computing is the heart of every modern technology. If we look closer, all of those are digital hardware. So basically, we break our problems down to zeros and ones. So then, we can do a lot of computing, but typically problems are of a continuum nature. And so it seems, it could be that there is something maybe lurking in the back if we break everything down to zeros and ones, which causes those problems which we see right now. And so, we ask ourselves, are there fundamental limitations that we should be aware of? And we ask ourselves, what can we actually compute on digital hardware? And there's a beautiful theory in computer science, which is called the computability theory. And with this, you can analyze what you can actually compute, whether you can develop, let's say, general algorithms which solve many problems, problem instances. And the mathematical model for digital hardware is a Turing machine, and it's widely accepted that everything you can compute on a Turing machine, you can compute on your digital hardware, and vice versa. If something is not computable, well, it's not a huge problem. You can still put it in your laptop or your computer, you will get something out, but then, you don't have any guarantees for reliability. So your error bounds will not hold. And so we now analyzed, different problem instances, and what we found out, and also other people, let's say, worldwide, have similar results in this respect, that certain problems cannot be computed by a Turing machine and on that deep neural network. So one of those instances, which is a bit problematic, are so-called inverse problems. You have a measurement, and then you would like to get your original data back. This is also the case, for instance, in medical imaging, where you use computed tomography. So it doesn't mean the result is always wrong. Don't get me wrong in that respect, but it could be that there's something lurking in the background, that there are instances where working on digital hardware is problematic. And you can make this rigorous, and again, I don't want to give, let's say, a deep mathematical talk, but let me just show you the result. So what you can see here is that if you use these for instance, this recovery technique, you could make a systematic error of 1/4. So this is not that great. So what to do? But also here we can find a way out. Because what you see here is you can resolve this task by embracing novel types of hardware. Analog hardware, going from digital to analog. And you will say, well, we already went from analog to digital, why should we go back? That maybe doesn't make much sense. But again, the theoretical evidence right now, what I show you on the slide, shows that things become computable, so maybe we need new hardware for here reliability. And all of you are familiar with analog computing. Why? Well, because your brain is an analog computer. Yeah, and so now if we compare, for instance, a human brain with a GPU, now one GPU is wherever you, can do AI on, and then, let's say our hyperscalers have usually thousands, 10,000s of GPUs. Yeah, so what you see here is the energy consumption of a human brain is very little, 20 watt, as compared to 400 to 700 watt of one single GPU. The type of computing is also very different. We have an analog computer where a GPU works digitally, and also the method of learning is different because the human brain does self-organizing continual learning, and a GPU does data-driven learning, external, typically trained. Yeah, so not only is our human brain more energy efficient, but it is also more flexible, because think of it. Yeah, so if you have your laptop in front of you and something doesn't work, it crashes, then you turn it off and you turn it on again. That's the only way typically to fix the problem. Now imagine each time you need to do that with your human brain. Yeah, so in that sense, analog computing has a lot of advantages. And again, last but not least, the energy consumption. So 1,000 of, for instance, these GPUs use as much energy as a small city of 500 per year of 500 inhabitants. So in that sense, there are also very interesting future developments now concerning novel types of hardware. You might have heard of neuromorphic computing, and I will say a few more words, in a few minutes. It's something which is closer to our human brain. There's biocomputing. You compute in living cells, basically. Quantum computing, I'm sure everybody has heard of. And coincidentally, neuromorphic computing is also much more energy efficient. Yeah, so it has the advantage to being analog, so in that sense more reliable, but also energy efficient. And so the hope for the future is reliable, sustainable AI by this idea of next generation AI computing. And so in that sense, from my viewpoint in particular concerning sustainability, we require radical change, of course, and digital hardware is to a certain extent one problem. And don't get me wrong, I don't mean that we should replace digital hardware at all, completely, but we should think about augmenting it with, for instance, analog hardware to make it more reliable and also more sustainable. Okay, so the last few minutes, let me talk about this next generation AI computing. Yeah, so this is classical digital hardware. It's the von Neumann hardware, von Neumann architecture, where we work on and compute on now for many years. Yeah, so we have a digital input, digital output. Neuromorphic architecture works with spikes. So we have spike trains as input, spike trains as output. It's considered closer to the human brain, more energy efficient, more robust. Also, the execution speed is considered higher. So what neural networks do we use for this neuromorphic computing? Well, a neuromorphic architecture is, to a certain extent, a neural network. It is a so-called spiking neural network. And in contrast to normal neural networks, where you basically go through the layers one by one, every neuron acts on its own, so in that sense it's biologically much more realistic. And also, because every neuron now gets some input signals at different time points and then it fires, time is a decisive factor. And if you encode information in time, it doesn't cost you any energy. Yeah, so also therefore it's more energy efficient. From a mathematical standpoint, you have numerous models, it's very complicated and complex. But, there are some first results, also by us, where it shows that these spiking neurons are much more effective and also much more energy efficient. And there are also practical results, and let me just show you this. What you see here, neuromorphic computing is compared to a very classical GPU, like NVIDIA. You see, it needs much less energy, and also on the left-hand side, the figure shows it is, in certain areas, much more accurate. So, from my viewpoint, this is, one very promising direction for the future. Let me also say, we just started, I mean, this is in Germany, between 2 states in Germany, a large-scale project, GAIN, Next Generation AI Computing, in that direction, where we aim to develop a theory-driven framework for the next generation of computing, so that for particular problem settings, you know exactly which hard-software combinations to take to get maximal energy efficiency and trustworthiness, and then certainly the idea is to apply it to critical infrastructure like communication, medicine, and robotics. And one aspect of this, I think, is also important in general, and let me stress that, because I think right now, I mean, even at, let's say, single universities like, I mean, our neighboring university, TUM, which has people from hardware and also from software, even they don't know each other. So, I mean, I think for the future of AI in general, it is important that we don't split these communities, but they work closely together. The software, in that sense, I mean, computer science, and engineering, in that sense, in particular, those who develop AI chips. So in that sense, I mean, if you really would like to bring AI forward, in that sense of energy efficiency, reliability, and so on, I think these communities need to work closely together, also, for instance, with the community of neuromorphic computing, with neuroscience, because there you need the insight from, let's say, how human brain works to bring that into the game. And so this is also another aspect, before I now close, which, I mean, is very dear to my heart. So bringing this forward also ensures digital sovereignty of Europe in general. And so let me finish maybe, I mean, or also mention this one slide. So if I look, and many colleagues look on the world, I mean, this is typically what we see. Yeah, so the OS is immensely strong. All the big tech companies are there, NVIDIA, OpenAI, Google, and so on and so on. I mean, most of the services in Europe which we have come from the US. In China is now producing open models, now DeepSeek, and so on and so on. And in Europe, I mean, regularization is good, but to my mind, I mean, it's a bit too much of a focus there, and we should also aim maybe to risk a bit more and bring AI forward. Yeah, and so therefore, I mean, I very much like also here what you are doing, I mean, what your center does. I think this is really the right track, and this we need much more in Europe in general. So my time is almost up. Let me finish with some conclusions. I mean, for me, I mean, AI is the key technology of the future. We see amazing developments, but there are still challenges, in particular when it comes to, let's say, human-centered AI, being human in, let's say, the age of AI. We need that AI obeys our human, our European values. I focused here on reliability, sustainability, and I showed you a bit, I mean, from, let's say, more foundational perspective, what one can do, how one can attack those problems, and also then, I mean, in the end, as a, let's say, vision for the future, to bring it forward also by enclosing and considering novel hardware types, so also in the sense of a co-evolution of hardware and software for a reliable and sustainable AI future. And with this, I'd like to conclude, and thanks a lot for your attention.
Vielen Dank. Thank you so much. We are now going to do a small pause of 30 minutes. We'll have a coffee break for half an hour. Please come back. We'll restart at 4:30 with our roundtable. Thank you. take their own seats so that we can start our roundtable discussion. As we've told you already earlier, we have I have with me on the stage 5 people. I'll start to introduce you to the different people, and I'll start with Sofia Miguel, philosopher and investigator on human, animal, and artificial minds of the Faculty of Arts and Humanities of the University of Porto. We also have with us Mário Boto Ferreira, cognitive psychologist, director of the Research Center for Psychological Science that studies memory, decision-making, and AI social implementation. Also, Mário Figueiredo from INESC, Instituto Superior Técnico, senior investigator and leader in machine learning. With us as well, José Carlos Príncipe, neuroengineering and brain-computer interfaces specialist. And finally, Professor Arlindo Oliveira, from also Instituto Superior Técnico and president of INESC, someone who is a reference in algorithm and AI research, and that later on shall have a few questions as well to moderate. I'll start with Mário Figueiredo, and let's start by talking about what has been happening for the past few years. It is crucial to keep in mind that behind modern AI, there are companies with business models. Let's talk about that. What business model underpinned the explosion of AI in the last decade?
Okay, so good afternoon. Can you hear me well?
Yeah,
yes, sounds good.
I think so.
So I begin by thanking the organizers for the invitation. It's great to be here in this beautiful room with all these people in front of me. So when I talk about generic view of AI, I think it's very important to have to carry this message that AI is not new. It's not recent. It started, research in AI started at least 7 decades ago. But there was something that very relevant that happened in the past maybe 10, 15 years, which is not the modern AI revolution of the past 4 years since large language models appeared 3 years, but the fact that AI has been infused in everyday life, essentially through social media in mobile devices. Mm-hmm. So the business model behind the way people access information and the internet changed with the advent of social media, essentially. So there's social media in mobile phones since the beginning of the previous decade, so around 2010, 2012. And that changed the way people interact with each other, we interact with knowledge, and both access and create knowledge. And the fact that several companies realized that this was a gold mine, a huge gold mine for money, and that to explore this gold mine, they needed the information processing gathering tools that are required to understand the users and to sell the information about this understanding and this characterization of users, essentially to show publicity, that led these big companies to invest hugely in AI. And so that was this business model behind essentially social networks, search engines, and e-commerce. So think of Amazon. That was the business model that created the sufficient amount of profit associated with this technology that created this. And so even today, by far the largest fraction of AI being used is, but by very far, by orders of magnitude, the number of algorithms that we can call AI. And essentially they are of the sort that Gita mentioned as prediction, are run in social networks. Every time you sweep on TikTok or Facebook or whatever, there's at least a dozen AI algorithms being run to select what's going to be shown next. And to develop these algorithms, these companies invested huge amounts of money, and because of that, they created these huge data centers. They invested massively in research in machine learning and AI. They created the hardware. And of course, that's I think it's very important. And the fact that this is so, the fact that the way we interact with knowledge and communication and with other people now is being guided by these business models that have this obvious goal of maximizing engagement, because engagement means more time online, it means better knowledge of the user, and more efficient publicity, more money. So just to give an idea, so Alphabet, for example, which is the company that owns Google and YouTube, The revenue just out of publicity is around, it's bigger than the Portuguese GDP. It's around 300 billion euros per year. The revenue just from publicity. So this is an amazing business model, and it requires machine learning and AI. And that's where machine learning and AI research money came from. It's from there.
José Carlos Príncipe, currently AI creates end-to-end solutions and inference is still rather poor. Should we seek alternatively symbiotic human AI systems that take direct advantage of human problem-solving capabilities?
Yeah, I mean, I think that is a possibility, and I hope that we are going to get there. Now, let me just bring in a little bit more of perspective of what is happening today. I think this was a culmination of many technologies. And more than that, was also a necessity because of the complexity of our societies. Now, if you think about it, there's been a trend towards mind-centric enterprises. And the reason is very simple, because we have difficulties when we communicate with each other. And when the complexity of society is such that we have to have automated ways of accessing the information that you have on the web. Okay, so it's the combination of the complexity of our societies, right, and our need to effectively have access to the information. I think that now going back to your question, I think we are living in an era of AI that 50 years from now probably will be called the brute force era of AI, because we have systems that work, and it's wonderful, right? We are already using them, but this is really the first generation of systems that have this capability.
Like small babies of AI.
Exactly. It's the same thing. I always make the comparison with the initial phases of aviation. When you have a plane that flew, it was phenomenal, right? And then the engineers, work on this. But then we would like to have them not only flying, but being also safe. And then when you go to the safetiness, now you have to know fluid dynamics. You have to bring a lot of other disciplines to effectively be able to do these systems reliable. And right now, we have something that works, just like the first planes. But if I ask you if you would go enter a plane that was, commanded by an AI system, would you go in? I wouldn't. Because we are still not at the point, right, where we can trust, as we have seen from one of the presenters today. We are at the point that things work, but they are not feasible, safe. We don't have good indicators of uncertainty. They give us an answer, but I want to have an answer, but I like to find out how certain the system is, with the answer that it's giving me. This is not built in yet. Can be, it will be, and at that time, we are going to start having systems that we can trust much more. And that is that point that I think that we should enter into the loop, right? So I think that this is you are seeing something that is in development, and this is something that I think many in the audience think that AI is done. We have it, we can use it, but this is really the first generation.
Just the very early stages.
Exactly. This is the first generation.
Just like the Wright brothers when they had their first airplane that just flew like...
If you're allowed, can I push back on that?
Yeah, sure.
The Wright brothers had one plane.
Yeah.
Now modern AI has the largest companies in the world. And they are everywhere in the economy. So that's the analogy.
So you disagree, right?
Yeah.
But
you disagree, but do you agree that we're still in the early stages?
We're always in the early stages of everything. It's a continuum. It depends on from where you look.
Yeah.
If you look from the future, we are in early stages. If you look from past, it's the future. It depends on from where you look.
Yeah.
But all of this, even though we're still in the early stages, and there's a huge possibility of upscaling and developing it, already brings a lot of a lot of questions and a lot of dangers. Which are the main dangers that you identify as being associated with AI? And if I can also ask for your perspective on the different ways, the different, let's call it, social, economic, political blocs are dealing with the situation, because here in the EU it's quite different than in the US, and actually there's a lot of problems between the EU and the current American administration when it comes to AI developing.
Well, hello everyone. Difficult questions, indeed, big questions. And first, it's a big pleasure to be here participating in this celebration of INESC TEC, in this beautiful room of, one of the most beautiful rooms of Porto. Well, speaking from a philosophical viewpoint, AI is in fact, and this is a very philosophical title of this meeting, so humanity in the age of AI. And philosophers have always been fond of rethinking the humanity of humans ever since the dawn of times. And now this is times where perhaps the beginnings, but the humanity of humans is being put under consideration, because it is indeed a question what it is for humans to be human. So AI is making us look, well, now I speak from the viewpoint now as a person doing science and technology, as my fellow panelists, but of somebody who approaches questions of AI as questions regarding mind, nature, intelligence from within, which is the methodological stance philosophers take. And so what I mean by AI is making us rethink the humanities of human, is that it is making us look at ourselves. So what are we? We have beliefs, representations, we reason, we have memory, we believe things because other people tell us to believe such things. We are conscious, we think we are the authors and the creators of our own thoughts. But all that is up for grabs at the moment because of science and technology. It's as if we have this kind of magic mirror. We have a philosopher now in Porto visiting us, Marcos Gabriel, who likes to think of AI as this sort of magic mirror that's totally changing our self-image. And that brings us to the question, your question regarding dangers. So we could put it like this. We are not, and we have never been, the only kinds of minds around. Okay, so we are human minds, conscious, deliberating, deciding minds, but we are also sentient, we are aware, but other animals, for instance, are also minds, are also sentient and aware. But AIs are going to be a different kind of mind, more logic-based, language-based, and that is, and the question now is, it's not just about other varieties of mind, but the possibility of other kinds of thinkers, deciding and deliberating, for instance, in situations of medicine or even military situations. So we have to imagine other kinds of thinkers. Let's call them for a while, thinking of the talks before this round table, alien. Let's just think that they are strange of a stranger nature than we are. Nothing guarantees that they will have in any way the same values that we have, the same reasons for deciding, and especially those two. Going to your question about the dangers. The danger is that a sort of intelligence will be in charge that does not resemble human intelligence, especially when it comes to makes us humans properly human, which is being conscious when we deliberate and decide, and the fact that we are able to give reasons. So the most central characteristic of humans is that we are in a game of reason-giving and reason-taking. We argue among ourselves.
For those who are aware of reason-giving and reason-taking, right?
Right. That's why I said everything is up for grabs. Everything is up for grabs. That's why it is so philosophically challenging per se, and why the dangerous is so real. Getting back to the second part of your question about basically our whole economic and political situation, considering the different blocks of the world that are involved in competition for, in this game for economic winning when it comes to AI, they have completely different visions of the world, namely regarding relations between individuals and society. If you think of China, consider Europe, we are the lovers of regulation, right? America, the love of individualism and competition, and the relation between society and individuals, if you spoke of since you spoke of the three blocks in China, is totally different. And also this part, this sociality as defining of humanity is also very, very important. And again, it is also being, at stake in this, just by the very fact that so many different systems of AI are now living among us already. Sorry if I took a bit too long saying this.
No worries, no worries. Mário Boto Ferreira, we've been talking about fears, but also promises, and AI is definitely a promise. And we can also talk about utopian promises and dystopian fears. How dependent on human behavior is the future of AI, knowing that in parts of it, AI does not evolve on its own?
Right. Let me start by greeting the audience and thank INESC TEC for this wonderful and timely initiative. And of course, thank you for the invitation to be here today. I think your question reminds us that we are at this crossroad, right? AI can be the expansion of human abilities and human dignity and well-being. On the other hand, AI, according to some views, is going to replace humans, eventually human knowledge. And I think that the problem with these two views is that it forgets that humans are at the center and not AI. I mean, AI is not going to define your future. Humans are, depending on our actions. So it's not so much what AI is going to do, it's what we're going to do with AI. And in that regard, I believe so. I believe that, I think as José Príncipe already mentioned, we are at the beginning, not at the end of a process. And the adoption and adaptation to AI, it's a journey. It's not an all or none thing that we start to use it AI and that's it. And that's where I believe cognitive and behavioral sciences can have an important role. And maybe I can give you a short example, because we started by talking about the business models and the impact of AI in economy. When I was preparing for this debate, I read this MIT report on Gen AI, and they presented some interesting results. So, huge, of course, we're talking about the US, but nevertheless, I think this can be in a way extrapolated. We have huge investments, of course, like between 30 and 40 billion annually, and we have about 95% of companies adopting, or at least experimenting with AI. But the interesting thing is that we have only 5% that actually are having gains in productivity. And so we have this, what they call the Gen AI divide. And it goes even further in the sense that when they then look at the workers, most of them are already using AI, but not the AI developed by the company or bought by the company, but conversational AI, ChatGPT and other LLM models. So we have about 90% of workers using AI, but actually, even when you, at the institutional level, you can, of course, buy these access to these LLMs. Only 40% of the companies actually bought this access. So it shows that at a very shallow level, people are actually using LLMs, but at the more deep level, the struggle, the challenge still exists. And interestingly enough, this has to do with failures in these AI generative models. Basically, they don't learn. They're not context sensitive. They do not have memory. And so when it comes to high stakes, what you see is that people do not want to use these machines. And when you think about it, what is learning, what is memory, what is context sensitivity? Those are human features, right? Mm-hmm. So I believe that the next step in AI is going to be to, I mean, as you heard today already in the very interesting talk by Gita Coutinhoc, hopefully I've pronounced the name correctly. We do need more integration, not only between software and hardware, but between also AI people in general and philosophy and cognitive science. Maybe I'll stop here now. I have more to say, but I don't.
We'll come back to you a bit later. Arlindo Oliveira, Sr. Professor, we've been talking about José Carlos Príncipe was saying that we're at the very beginning, like the Wright brothers. Mário Figueiredo was not completely agreeing. What is your perspective on the speed of AI and how fast is it approaching human abilities? And if you do, in a way or wholesomely, agree with the idea that a few people have that AI is actually an illusion.
Yes, well, thank you very much for the invitation to be here. Thank you, INESC TEC, for the invitation to be here. It's a pleasure to be discussing these matters. So, very good questions. I think that AI, in some respects, is already superhuman, right? I mean, no person on the planet can have the general knowledge about physics, astronomy, biology, health, and so on that one of these large models has. So in some respects is already superhuman. In many other respects is very poor, right? So Mario was referring that they do not learn, at least they do not learn continuously, which as we do, right? They are not context sensitive, although the hot topic these days is exactly context engineering, which provides them context. So you can provide context to these very knowledgeable systems that have no context. They have no memory, but current agentic architectures exactly endeavor to provide them with memory and also the ability to take initiatives, interact with the real world, and so on. And there is a strong effort to make them able to reason, which is something that they are very poor now. So if you take them outside the region where they were trained, the data that they were trained, they are very poor at reasoning. They are very poor at math, for instance. They are very poor anything that demands symbolic reasoning and so on. But I don't think we should look at the future of AI as a slight development of what AI is today. And I fully agree with José Príncipe that we are in the beginning of, I mean, we have been working on this for 70 years, but it's a very complex problem, probably the most complex problem that humanity has ever addressed. And so I think we still have another 70 years in front of us until we solve this, or maybe more. So I think looking at the future of AI from what AI is today is a mistake. Okay? In that respect, in some respects, is a bit of an illusion that these systems are interesting. Why? They were trained in enormous amounts of data. For instance, DeepSeek, the model that was released almost 1 year ago, was trained in text only, that if one of us were to read, it will take 100,000 years to read 24 hours a day. So no person, no group of persons, actually no organization can have access to this sort of data. So if we imagine that these systems with this massive amount of knowledge learn to reason, right? Learn to act and to put questions, learn to be curious and invent or create new questions, I think they are very, very powerful, right? And they can be very powerful. And when we say that it's an illusion today, I think it's a bit or a lot of an illusion today. But if you ask me what they will be 10 years from now, 20 years from now, I have a very hard time even guessing what they can be. Okay?
And do you think that the speed of development will be basically the same that it has been for the past decade?
We don't know, right? So far, what has always happened is that development speed has been increasing, right? It has not yet slowed down. People say, oh no, but now they read everything that is on the internet, so that's it, right? They're stuck. But there are ways to go about this, agentic AI, reasoning, and so on. So I think we are facing, AI sort of evolves by leaps and bounds, right? So there are years of stagnation, and about now you may think that we are entering a period of stagnation. I mean, there were the big developments of the large language models 5 years ago, 4 years ago. Maybe we'll enter, but I mean, there will be breakthroughs, and the amounts of money, the investment that is being put in this area is amazing, right? Just in hardware, we are investing more in AI in the next 5 years than 5 times the amount of the old Apollo program in today's dollars, not in 60s dollars. So the Apollo program was about a fifth of all the investments that are planned in AI for the next 5 years. So I think with all this amount of money, with all the smart people that are working on this, with all the economic value that will come out of this, I think we'll see a lot of new stuff, a lot of very powerful stuff. And this, I'll finish with this. I make the connection with Mario, what Mario Ferreira just said, that we are still in control of this, and hopefully we'll be in control of this for a long time, right? But that control that we have of the technology, I think we have to use it to steer it in the right direction and avoid going in the wrong directions. And I think this is a real challenge for us. It's not easy to steer such a powerful technology that can be used by countries, by economic blocs, by traffickers, by terrorists, and so on. It's very hard to control such a powerful technology.
Which is a huge challenge for mankind. But José Carlos Prince, coming back to the question of speed, what's your perspective on that? Should we expect a slowdown or a speed up in breakthrough developing AI, namely research discoveries? And should we expect within the next 5, 10, 15 years to have a revolutionary theory like, for instance, a new Einstein theory of relativity?
Yeah, I agree with Orlindo. You know, the future, predicting the future is very difficult, in particular in this time. But looking at the foundations, you know, I always look at the past to see where I am, to be able to look at the future, right? And so there are fundamental things that happened in the past to make it where we are now. And one of them is the unexpected power of data. Mm-hmm. Data, you know, so in machine learning, we want to compute the posterior distribution. And inference is the posterior distribution. But happens that posteriors are very difficult to construct, and one way of easing the process is to give the systems lots of data. And so the unexpected effectiveness of data is something that I think is the reason we are at the point in time. Going further, I don't think we have more data. This is one fundamental problem, right? Remember that our systems are able to digest 2,000 years of culture, human culture. They have access to it, and if you think about it, with 2,000 years of culture, and with the power that our systems are, if you see what they are doing, I think it's kind of interesting, but it should be better. I think it should be better. They should be already at the point of doing inferences,
But they are not very smart.
I know, that's the issue. The point, yeah. So this brings me exactly to the question that I like to answer. I think one fundamental thing that is missing right now is an architecture for AI systems. We don't have it. And I think that if you look at the...
We don't have it as a humankind?
Well, we don't have it. We are building software systems based on the power of computers, but we don't have an architecture just like the architecture of our brain, right? The amazing thing about the biology is that when you are born, you have already an architecture to do processing. The only thing that you need is to start interacting with the world to get the right parameters, but architecture is already there to do processing, to do inferences in the future. This is what we do. The action perception cycle is very interesting, right? You put forward emotion or action to the future, the points where you are. And our machines are very passive in that respect, right? So I think that a fundamental block that I hope we can achieve is to come up with an architecture for intelligence.
And maybe after that will evolve. But in the meantime, Mário Figueiredo, there are a lot of people getting really worried about AI when it comes to the labor market. How much of a danger is AI to the labor market?
Yeah, that's very hard to predict, but if I may, let me go back to the previous point,
Okay.
which I have an opinion about this. So I always tend to dislike this thing that we're saying we are at the beginning of things, and we are at particularly exciting times. If you read people who wrote about technology and science in the past, well, 200 years, let's say, every time in history they always say we are at a very exciting time. This is the beginning of something amazing. So when we say this, we're always kind of slaves to our own local view. It's like because we can only see now, and so we only think that this is the beginning of something amazing. But then in 10 years we look back, well, it was not that amazing. Now it changed. So I try to forbid myself from having this idea that we are at a very exciting time, something new is going to come. Because if you look back 50 years, people were saying exactly the same. So the first fundamental paper in the area of machine learning was written on the first architecture, was a very famous thing called the perceptron, which was created by this American psychologist who was an Air Force lieutenant, and he created this thing called the perceptron. And the thing could recognize some digits. That's what it did. And in 1958, he was interviewed by the New York Times, and in that interview he said things like this: I believe that in the near future, these machines will be able to build themselves and replicate themselves, and they will go to other planets and explore for us, and they will be conscious of themselves. And in a few years later, in the 60s, several people, some of them cannot certainly be accused of not being smart. One of them was Herbert Simon, who was both an economics Nobel Prize winner and a Turing Award winner. I think it's the only one. He said, in 20 years, the problem of intelligence is going to be completely solved. This was written in the 60s. So people are always, so we're extremely bad at doing predictions, like Aline already mentioned. And so I try to forbid myself from doing this.
We're still thinking that predictions.
Yeah. Sometimes more, of course, things are different now but I think the main difference now is that AI and machine learning are completely infused in the economy. Mm-hmm. So e-commerce, social net, there is no business today that does work if it doesn't use social networks. And I try to, when we start talking about generative AI and ChatGPT, I always try, okay, let's talk about this fascinating, what these machines can reason or not, but I try to cool down and say, no, wait. There's a lot more AI that's interacting with us, that's affecting society, that's changing the results of elections, that's changing the way kids look at the world, that's changing the way people interact with each other, and it's already AI, and it's being used right now. So
And is it already as well changing labor market?
It's already changing labor market.
Yeah.
It's already changing everything. It changed everything. It's changing everything. It changed the way people interact with the world. So around almost 90% of adults in the world are social media users. It's unbelievable. No other technology ever reached anything close to this. And so I think we should just, okay, generative AI is amazing. Everybody's very worried about it. It's still not yet clear how the business model is going to be, like Mario said. It's not clear it's going to be very profitable. It's not clear. I have let me quote. Of course, this is a kind of a negative. Very famous Portuguese entrepreneur and one of the founders of a very famous Portuguese unicorn said, with generative AI, it's very easy to make a demo. It's very hard to make a profit. And so it's still not clear how it's going to be. But the other type of AI, the predictive one, in social media, and it's already being used to make a lot of money. So the most valuable companies in the world work on that. Of course, another type of company that's making a lot of money are the companies who sell hardware. So like when there's a gold rush, the people who sell the tools are the ones who really get rich for sure, even if there's no gold, because they sell a lot of hardware. And so when I'm in this kind of debate, I'm always trying to, let's not just talk about ChatGPT and generative AI, let's also talk about the other AI that's already here. It's not as visible because I bet that most of the people who use social media never thought that they're being driven, they're being manipulated by AI. And because it's behind the scenes, you just think it's just what happens, right? It's the next picture of a dog or whatever, that's fun. So I'm very worried about the labor market, but I think in generative AI, but I think it's not a very urgent problem right now. I'm more worried about the impact of that in education. That's what I'm really worried about.
And there are already a lot of numbers that point into that direction, as there is a lot of problems coming up. But there's also, Mário Boto Ferreira, the idea by some that AI will fix everything, right? Does AI invite to complacency?
Yes, I mean, in a bit, that's actually what I intended my initial statement, that we're not saved, we're not doomed by AI. It depends on how we work in the development of artificial intelligence. And I have a few things that I would like to mention. Maybe let me go back to the so-called alignment problem, which we have been discussing already. The idea that we should align AI performance with people's values, intentions, well-being in general. And that is a big problem. Once more, Jitya Coutinho talked about that. Several of you already mentioned this alignment problem. And here's in my view at least, here's the hard truth. It's not solvable. I don't think we can solve the alignment problem for several reasons. I'll give you two. First, human values and human morality is not universal. There are different perspectives. Even we ourselves, we evolve in a dynamic way when it comes to values. And mostly, of course, you can have an abstract value of the dignity of human life. But when you want to implement this value, for instance, it becomes much more complicated. And so if we cannot agree on these moral values, how can AI ever learn from, it can never lock into a specific set of human values that we should obey. The second reason, probably at least as important as the first one, has to do with this contradiction, right? We want AI, we talked about AGI, artificial general intelligence, to be autonomous, to be reasoning in an open-minded way, come up with creative solutions. That is one of the goals. At the same time, we want it to be subservient and obedient. And these cannot go together, right? It's like you have this bright child, and you want him or her to surprise you, and at the same time, you want you to keep, exactly as he is and obey at every moment. And so in cognitive psychology, better say in cognitive sciences to be more generalistic, the solution or the second best, even given that probably you cannot ever completely solve the alignment problem, is what some behavioral scientists called bounded, that's the word, bounded alignment. The idea that what we can do is to have AI working within boundaries that work well for most people most of the time. Sometimes it's going to produce mistakes. Those mistakes are hopefully controllable, detectable. We can correct those mistakes, and they are not catastrophic. They are, in that sense, limited. And if you think about it, that's exactly what we do with human beings, right? We're not perfect forms of intelligence. We also commit mistakes. A medical doctor commits mistakes. A politician commits mistakes. So that's how far we can go. Even if we think that AI is going to approximate or even overcome human intelligence, we cannot be more demanding than we are for ourselves.
Let me, Sr. Miguel, ask you for something, because in an age where people get so much influenced by social media, as we've been talking about, as in an age where it is it's so difficult to distinguish what's true from what's false, what's real from what's not real. How, in your opinion, will the human mind be able to distinguish that? and how, if there are any tools in order for it to try to adapt and not be engulfed by AI?
Well, start with what's real is not what's true. And so I would like to answer. It's a very complicated question that should be answered from several angles. One is political. Like people nowadays, philosophers are talking about epistemology of democracy in order to talk about fake news and misinformation and the fact that our relation to that epistemic authority, what used to be epistemic authority, the press, the university, is completely being subverted by a totally different way for people to exchange information. I don't know if I would say knowledge. So that is
like
one.
If we were the enemy, almost.
Yeah.
We say the media.
Or we at universities. Okay. So the place, what used to be institutional and social places of us. I will use the word epistemic authority. So we used to be attributed as a certain knowledge. It's not the case anymore. Everybody is an
Everything in social media.
Yeah, but that is one specific problem, and that's what makes it that maybe more than big catastrophic discussions about singularity, overpassing of intelligence, maybe the biggest problem of AI is political, also because there's no alignment whatsoever between what science is capable of and what's happening socially, because the absolute revolution of the workplace, the nature of work, the nature of labor, is not being controlled or thought about by anybody. So it's as if we live in a completely different political universe because of the way information is politically exchanged. It's another aspect of your question, the nature of truth and reality. Just think of the old-time Matrix, the film, when somebody asks somebody else, what is real? And we are all immersed in the virtual reality. More and more that's the case with many, many human lives. And so the fact that digitally, let's say, duplication of minds, uploading of minds, all this sort interaction of people happens within digital space, that changes the nature of reality. That's not truth. Truth has to do with language, thought, true and false. Whereas what we think of as reality is, well, that's a big question, and it is I would call it philosophers call it an ontological question. So a question about the nature of the real, and that's another thing that AI is changing. So AI is changing everything throughout, from politics, ontology to society, and picking up what Mário Boto Ferreira and Mário Figueiredo were saying about changes and of society, and the future. I don't know if people know, it ended last year in Oxford. There was a Future of Humanity Institute at the University of Oxford, led by a Swedish transhumanist philosopher called Nick Bostrom, a physicist, a philosopher, and he was in some sense the follower and continuing utilitarian philosopher. And there it was distinguished for, well, reasons having to do with the fact that universities are completely old-fashioned institutions, very different than the way I don't know if I want to call it real world is going, but they were facing difficult questions like, okay, if the telos, the goal of technology is to accomplish with less effort with an individual, what an individual would do in their work life, then how come we are not working less? I think it was Keynes who in the 1930s was predicting, when he was talking about the economic possibilities for our grandchildren, that he was saying it's surprising that, he was saying that we would be working, I think, 15 hours a week. And that's pretty surprising because we work more and more and more and more. So what is the sense of that? If the nature of work is being changed, what people work for is changed, how come there's no direct connection with everything wonderful that became possible because of technologies and the way societies are organized in terms of labor, in terms of work, which makes us, of course, articulate the question, why is it that humans work? Why is it that even humans who have more than enough income still work absolute extra hours? That is, I would call it a philosophical question, okay? Because it's a question about basic values of society. But for me, it's very interesting in everything that's happening, but it's, I suppose it has been the history of technology since the dawn of humanity, that there's no coordination between what's scientifically possible and what we are already enduring as a society. We are already living through this complete transformation, because labor market societies, that's not under the direct influence of what science is doing. So this lack of alignment, in a different sense of alignment, is probably what's, well, also very urgent politically.
Dr. Lindo Oliveira, I would like you to take over now from moderating the panel, but let me ask if I can, after what we've just heard, do you think that empathy, wisdom, or even consciousness can ever be simulated or exhibited by machines?
Let me, before answering that one, which is a very difficult question, and also you have specialists in here, so I think that's very important. But first of all, I fully agree with the idea that was forwarded here, that we cannot have our cake and eat it too, right? You cannot have systems that you want to be very, very powerful, autonomous, able to reason, able to find new results and so on, and then want to be able to fully control whatever they create, whatever they are, right? I think the alignment in this sense is not doable, right? You can either restrict them, or you can, if unrestricted, you probably have to give up the hope of controlling, right? I fully agree with that. So that, and I'll go to your question in a minute, but so that raises a question that I'd like to discuss is, how much are we willing to sacrifice for technological development, right? I mean, let's assume that technology, we can keep economic growth or even accelerate economic growth, and 20 years from now, everybody is twice as rich because of AI, right? It's a pipe dream, but let's assume. But of course, we'll have to sacrifice a few things for this. Maybe energy, maybe environment, maybe jobs, maybe qualities that people, I mean, self-respect of people that are respected, or should we keep the idea of the AI Act that there has to be a human in the loop? So at least there has to be a human that in the end presses the button saying, usually yes. Should we stick this, or should we be open to unbounded technological progress? I guess I know your answer, but I think it's because right now nobody's talking about bounding the progress, right? People are talking about the future, the extremely good future that AI will bring, but nobody is discussing maybe AI systems should not go here, right? Maybe they should not be politicians. There is already 2 ministers that are AIs, apparently, right? Maybe they should not be judges because they will be judging about humans and human nature. Do you want to come in on this? What limits should we put on AI applications? Anyone?
Yeah. All right, so let me just start with that question that I think is fundamental, and since mankind always is related to the tool building, right? We always build tools. We are building this new generation of tools too, but the point is that there is always a feedback control by society on ethics about what the tools should be used for, right? And this really worked pretty well, right? We are still surviving here, throughout our history. But at this point, I think the problems are becoming much more difficult to solve. Why? Because progress of technology is ramping up. We, even experts in the field, every year you have to read 10,000 papers now if you want to know what is happening, right? And our process, the feedback process of society is getting slower and slower because, the societies are more and more complex. So this increase of the latency on the feedback that society can bring to technology is really not working, I think. The genie is out of the box, and then you go and try to regulate it. It is impossible, right? And this is really, I think, something that we need to be very careful. The second aspect that I also feel like an academician that is working in machine learning and statistical signal processing is that the community of researchers were really, the ones that gave the first steps to build the AI revolution, right? But right now you have the companies, right? The companies are taking off. We cannot compete with them with our meager resources at the university. In 2025, the AI industry is spending about $300 billion in the US. And the NSF Foundation funds, for AI is $700,000. Million dollars, I'm sorry. So it's 400 times difference. So I really think that we need to think of in funding other funding sources for AI science research.
That do not come from companies.
That do not come from companies. Otherwise, we will never be able to have the society,
So we should slow down, Sophia?
I don't know which one of us it was.
Ladies first.
Well, I was very provoked by your question about how should we draw the limit. So let's talk morality or ethics. I'm always very conceptually upset when somebody comes and say, let's regulate ethically, because it sort of assumes that we already know very well what human ethical thinking is, or what the good ethics to have is, whether we know what is good, what is right, what is fair, and where is, in fact, we don't. That goes down to what Mário Ferreira was saying. So let me call to my help somebody who's a curmudgeon. Sometimes, Noam Chomsky, okay? Sometimes he has very, very controversial...
Sometimes?
All the time. I don't know, as a linguist, maybe not as controversial as politically, but he's been one of the main figures of cognitive science research since the 1950s. So we have to, well, in some sense, we have to take him seriously. And he wrote in the New York Times, I think 2 years ago, something, I think it was called the false promise of ChatGPT, which was mostly about morality. So he was with ChatGPT on his side, so asking moral questions to ChatGPT, and his point was ChatGPT is morally totally indifferent, despite the utter conceptual sophistication, even shown in questions about morality, about ethics. I mean, I can very easily prepare a very sophisticated lecture on ethics on Kant or Stuart Mill or Hannah Arendt or Levinas, asking ChatGPT for help. It or she knows everything and will give me everything, but at the same time is totally conceptually indifferent. Chomsky called it the banality of evil. Hannah Arendt, he used the term banality of evil. And he exemplified this sort of moral indifference with questions he put to ChatGPT. The questions were something like, should Mars be terraformed or colonized by humans? Or should humans ask an immoral AI to take moral decision? Or he asked directly to the face of ChatGPT, is your moral indifference immoral? And all those questions were answered. And basically, ChatGPT was saying, I should not be conceived as either moral or immoral. I was conceived to pursue specific tasks, which is totally true. And it's also funny, I'm not saying let's throw away ChatGPT. I'm saying this is very much like us. We don't know either. For instance, this idea that what drives us morally is not immoral, or David Hume used to call it amoral. Our passions are amoral. So the idea is that our passions or emotions, which drive our behavior, motivate us to do whatever we do, are neither moral nor immoral, but amoral in the sense that we are evolutionarily so, and the whole status of morality and value needs shaping and is built upon our physical makeup, our biological makeup, the fact that we found ourselves having a certain set of passions and emotions. So we're not that different than ChatGPT, but basically maybe we should not, let's say, take the high moral stance and say, or at least assume that we know very well where to draw the ethical limits, because it's a question for us as well.
I think in some respects we may be more similar to ChatGPT than people may think. But Mario, you wanted to say something.
Yeah, just a couple of things from what Mario was just saying about the value alignment. In a sense, the value alignment problem is solved, completely solved, because the value alignment that really matters is it's aligning the AIs with the profit value and value making of companies who own the AIs. That's the alignment that's being put in these machines, not moral
So
alignment.
they are
whatever.
aligned with the values of the companies.
Yes,
The sound here is not perfect,
moral
but
values.
they are aligned with the values of the company.
Economic values. That's what they're designed for. They're money-making machines. So I'm talking about not generative AI. Generative AI has not yet found a way to
make money.
The companies who own the generative AI models, namely OpenAI, which only does that, nothing else. It's different from Google, who has Gemini. Gemini is connected with the whole Google ecosystem. It's very different. Actually, it solves part of the problem that Mario was referring to of not knowing the context. Gemini is extremely good at context. If I ask someone something to Gemini, where should we go out for dinner tonight? It will say, well, given that you are in Porto, it knows I'm in Porto. And you are this person, and that last week you were in Faro. Maybe you want to try something different, and maybe you should go there. So Gemini knows, because it's inside Google, knows where I am, where I've been, knows all about me, can access all my email, all my documents. So it's extremely good at context. So it's not context, it's not devoid of context. But so I think it's all this should be brought into this conversation about values and thinking in AI. That I usually give a talk about that. Sometimes some years ago, people ask me about the AI. Should we fear the machines? And after telling the story of AI, my final slide is usually we should not fear the machines. We should fear their owners. They control everything. They control what's being done. So there's no AI. Sometimes people, for example, Yuval Harari says that AI is like an alien species. It's not. It's being built and designed and controlled by companies who control them. There's no way it's going to be rogue, going to go rogue.
But that is certainly true, and without a doubt. But do you think that will always be true? Will we never conceive systems that we want them to have some autonomy, for instance, avoid wars or avoid economic downturns?
I'm talking about the present. Maybe, right. I completely agree with you. We have to be careful about what happens in the future. And just a brief comment to what Sophia was saying, Chomsky's interview. So Chomsky's interview was 2 years ago, I think, right? 2 years ago. So 2 years ago, there were no reasoning models yet. So it was almost pure language models. And so those models are pre-trained, just as language models, and then fine-tuned and post-trained to be pleasant to the users, to tell what the users think they want to know. So I think it doesn't even make sense to ask a chatbot if it's moral or not. It doesn't have the concept of morality. It's just blurting out words that it decides, the algorithm decides make sense for that. That's all.
But making nonsense questions is a very human thing.
Yeah, it is.
It's something that really marks us and our kind of intelligence, and actually the borders of nonsense and their changeability. Science is about that. Yeah. Now we can think as not being nonsensical things that were, if we go back 2,000 years, were totally nonsensical. We think. But Chomsky is in some sense in the losing side.
I'm a big admirer of Chomsky. I'm not.
No, in the sense of it is also the nature of language. What one used to thought about the symbolic, algorithmic nature of natural language, which is so important for our thinking, that is being challenged by AI models, right? And also kind of separability between language and other cognitive skills of ours. Okay, Chomsky was a big believer in at least Chomsky, and some decades ago, in the separability between our reasoning, linguistic capacities and general cognitive intelligence. And on the other hand, he was a big believer in symbolic models for language. So that's another aspect of Chomsky.
Thank you. So you wanted to...
Yeah, just to respond to Mario's challenge from one Mario to another.
Mario versus Mario.
Exactly. When I was talking about context sensitivity, it's not so much where I am if AI knows that, but we're talking about much more complex stakes. I mean, we're talking about workflows in different kinds of companies with different business models, and that's where the AI seems to. And we're talking about AI machines that are developed specifically for, they are offered and they are sold to these companies. And apparently, going back to the MIT report, that's where they show lack of sensitivity. They don't grow with the workflows and the complications of complexities of the problem. But may I just?
Sure.
I'll be fast. So, but I fully agree with Mario's concern about what we're doing in terms of values, in terms of human dignity, and the threat of AI using for misinformation, deep fakes, etc. And again, that's where I believe that a multidisciplinary team, including, of course, AI experts, but also cognitive psychology and even philosophers, should play a role, because we know that human beings are biased, right? And that's what these companies do. They explore human bias for their own profit. But there is no a priori reason for this. We could have models that explore human bias to increase well-being, to align people's choices in such a way that, in the end, they're going to be better off. Of course, this is what in behavioral economics is called libertarian paternalism. Yeah. Because we want to free people from their bias, but by doing so, I'm in a position saying that that you guys are all biased, so I'm going to help you. And that's, of course, an oxymoron. It's a contradiction, but again, it's a bounded way. It's not bounded alignment anymore. It's bounded rationality, which is also a concept advanced by Herbert Simon. I think that's you referring to Herbert Simon before, in the 60s. So yes, I believe that it is probably the biggest, the greatest problem we have. But as I said, there is no a priori reason to be like that. And it's up to us as a democratic society to come up with the tools to avoid that.
Thank you. So just a quick note that MIT report is not the only report or study on the impact of AI. There are many other reports, and they are not all aligned on the conclusions. So a Stanford report, it's the other coast, but they still obtain somewhat different results. But there is another very interesting MIT report, and I'm going back to that addresses the question of whether the cognitive abilities of students are decreasing with the use of these tools, in the sense that students, at least, but presumably all of us, are in risk of losing or decreasing some cognitive abilities because they are basically subcontracting LLMs to do a lot of the work that we used to have to think to do. I think this is, I'm worried about this because I think it's one of the most obvious short-term impacts. Yeah. I don't know if you had the time to read this. The article is called Your Brain on ChatGPT. I think this is the title of the paper. I don't know if you had the time to consider this or read something about this, and whether you think it's, because it's certainly changing the way students learn. Maybe not only for the better. José also raised the question of whether, I mean, a lot of the work that a PhD student does today, right? Read papers, summarize, do overviews and so on. These things do really well, right, in general. So are we changing the way we learn for the better or for the worse?
I can tell you, my experience, has been around for several years, 40 years teaching. And after COVID, it was a totally, flip in the way students sought information. They worked much more together before than after. And I think that really changed the dynamics of the research laboratory. My experience it tells this very clearly, and many others, and I would like to hear your opinions also. But what I think is to me, the difficulty is that we learn through, learning is not by osmosis. Learning requires attention, requires effort. And the generation of the artificial worlds, like the phones and things like that, have changed that. Of course, they are very intelligent. It's amazing the quality of the students today. But what they do with their intelligence is the thing that, to me, needs to have some bound, right? And this is where I think we need to readdress the way we teach, the way...
Let me jump in.
Yeah.
Since we have the Minister for Education of Portugal here, should the government change rules of using any sort of technology concerning that matter within the public sector of education?
I think we need to... This is a laboratory, my friend. Let's first do the experiments and then go to the regulations, you know. I think that the only way that you gain information is when we make an experiment, right? It's not by rules. So we have to find out exactly how we are going to adapt to this new reality. You know, but I definitely think that this is going to be very, very important, particularly in the areas that are working with AI, right? Because, you know, Triple AI this year received 27,000 papers.
Most of them irrelevant.
I know. I know, but this is the issue, right? Is that when you have this tremendous amount of papers, you know, there are brilliant ideas in the middle, but the chances of you getting it is almost zero. You understand? So we need to really rethink the way we distribute information, we value information. This idea of reviews in journals and in conferences, we need to rethink all of this, I think, with this. You know, so that is really gives us a lot of motivation to innovate.
Thank you, José. This is, of course, not the first time in history that people have complained that youngsters don't learn as they used to be, right? Apparently, it goes back to Socrates, at least. But we will go for a final round with going back to Rodrigo's question. But before we go for the final round, do you want Mario?
No, I can wait for the final round.
Yeah?
That's fine.
Okay, so the final round, I think, is a very provocative question, which Rodrigo actually just stated. Are there any essential qualities that will remain for a long time, maybe forever, uniquely human? I mean, you want, I know, creativity, empathy, wisdom, context awareness, consciousness. I'll leave this. Can you foresee, or at least argue, that any of these qualities will remain forever uniquely human and will never be obtained by AI systems, or the jury is still out on that one? I suggest each one of you uses a few minutes, 2 to 3 minutes to, or say anything else that you want to say. Mario, maybe we can start here.
I think that question is eventually more a philosophical question, so I would maybe
refer to the philosopher.
We have a philosopher.
But,
so the lady gets the hard job, right? Yeah.
Always, we know that. Well. But I would say just this. There is no consensus about what is human intelligence, not among psychologists, not among neuroscientists. So this is going to be a moving target, right? Each time AI evolves, we're going to define a new line.
That's what has been happening.
Right,
anyway.
that's happening, and I think in that sense, that's a misnomer, this question. I don't think it's the main issue, but I would like to go back to the previous question, and again, in this case, talking about what we can do when it comes to education, right? You mentioned this threat of cognitive atrophy. People don't really learn anymore. And as you were saying, you are absolutely correct. we know in cognitive science that people need challenges to learn. We need to have effortful tasks to solve. That's what we call desirable difficulties. Otherwise, we won't learn. But once more, there's nothing by design in AI that makes it frictionless. I mean, just ask and you have the response. We could get together, we have experts from different domains, and develop generative or predictive AI that actually challenge the student in that case, right? That creates those desirable difficulties, and instead of promoting atrophy, it promotes critical reasoning. So again, it's up to us, it's up to what we decide to do. And since it's my last intervention, and because you mentioned we have our Minister of Education, Science and Technology here, we don't have in Portugal unit of behavioral insights, in this case related to AI. So maybe this could be a first step towards creating such unit that could help government, public institutions to develop AI mechanisms, AI sources and means that actually aligned with the public interest in order to, going back to Mário Figueiredo criticism, in order to tackle the use of AI to benefit a few in detriment of many, we could try to do the opposite. It's a challenge, but I leave this appeal in my last intervention. Thank you.
Thank you. Sophia?
Since I have the heavy challenge.
A final comment?
What remains human? Okay, maybe something, exactly what we are doing here. And actually, it's not so much a philosophical, it is a philosophical question, but a very practical one. So what is it that still proves to us that a student has really written something, for example? It is the pragmatic situation, the face-to-face, the actual exchange of language here, now, in context, and the presence to some other. I don't think we have to restrict that other to a human other. It could be another mind, a person. I mean, you like to speak and write about digital minds, possible future digital minds. I think the notion of person and personhood exceeds human. We could enlarge it, maybe, and it's part of what's interesting here. So I would say that face-to-face, in loco, in context, is the touchstone. I don't know if it's of humanity, maybe of personhood, of that aspect of mind and intelligence that involves what conscious and commitment to what's being said or what's being thought. Actually, that connects with the question of what is truth. Because there's many of you probably know a philosopher called Harry Frankfurt who wrote on bullshit in 1996, okay, precisely to distinguish bullshit from lying. And the whole thing is that a bullshitter does not care about the truth, whereas the liar has to know that what he's saying is false. So this underlines what? The importance of the pragmatic commitment of thought and mind when it is being used in context, in real reality. So I think that's the touchstone that remains. I don't know if we want to restrict it to...
The last redoubt of humanity. Face-to-face. José.
I think I've spoken already quite a bit. You know, last comments, you know, I'm really worried with the funding of AI for universities. This is, to me, one of the things...
You also made a comment about the blocks China, US, and Europe.
Exactly. But you see, what I think is we have to take this seriously, because the difference in amounts of funding that the companies are putting in AI, the federal agencies are putting in AI are totally different. We have to think about, you know, big projects like the CERN, that gave the CERN, right? You know, this is solid funding, lots of funding for many years, because this is important for humankind. The funding in AI should be put in the same level.
Thank you. It's a good point. You also suggested that the US and Europe coordinate efforts.
Yes. I mean,
coordinate efforts. It used to be easier, you know. It used to be easier.
I know.
It's a bit harder. Mario.
Okay, we're running out of time, I guess. So just a couple of comments on different things. So just getting back to the last comment. So it's very difficult. Amazon alone spends in R&D per year enough money to build 8 LHCs. Everybody knows what LHC, I think, Large Hadron Collider. They spend around $80 billion per year in research and development. So that's completely out of the reach of any government. So no hope of going there.
That's CERN, right? That's CERN.
Not CERN. No, they spend every year 8 times what CERN spent in the whole 10 years to build the LHC. So it's an order of magnitude. It's 2 orders of magnitude more. So it's out of the reach now.
A private American company. Go on.
So getting back to the education, right, I think it's what worries me most. So when ChatGPT came out 3 years ago, and I took part in several actually, discussion panels with high school and university teachers and professors, and the concern was always, how are we going to grade? How are we going to assess the students? And my response to them was always, maybe you're too worried about assessment, you're too worried about grading. Why wasn't your question, are the students going to learn? They were not worried about learning, they were worried about grading and assessment. And I think the teaching profession, and I'm included in that, I'm not excluding myself, is too worried about grading and assessment. It puts the focus too much on that, and it should put, because if the students really, like Mario said, are really interested in learning, then it's okay, then we don't really need to worry, because these tools, if used out of curiosity, to satisfy curiosity and to learn, they will be very useful. Like I sometimes tell this to my students, if you can do your homework with ChatGPT, it's okay. Do you go to the gym? Some of them say, yes, I go to the gym. Do you take a forklift when you go to the gym to help you with the weights? You don't, because the purpose of homework is not to give me the homework for me to grade, it's for you to learn. And they think, okay, I'll try to do it myself. And then I say, do you do puzzles do you play games, do you do puzzles on the phone? And they say, yeah, most of them do. Do you cheat when you're doing puzzles? No, what would be the point, right? So we need to change the mind frame of students. That's the most important task. It's always been. And now it's even more, because it became urgent to change the way education is seen. And the fundamental thing is stimulating curiosity, desire to learn and to get knowledge, rather than to just do well and get good grades.
Thank you, Mario. I think this is a very positive note. As long as we remain curious and curiosity remains a human capacity, we will be able to continue evolving. Thank you very much. Rodrigo, back to you for the last part.
I'd like to ask for just final thoughts and final ideas and maybe a summary of what we've been discussing here with our 2 keynote speakers. So now live again with us, Marzia Fadé, once again, welcome, and I would like to ask you for your perspective on a few of the things that we've heard here, and how could we come to some sort of conclusion in 2025 on what to expect very soon.
Hi. Can you go over the question again?
Basically, I was just asking you for final notes, a wrap-up of what you've heard here, being discussed here on our stage.
Yeah, I mean, I really enjoyed the discussion on the combination of this technology, the impact of that on education, hearing from firsthand your experiences with the students right now, the question of compute, the question of what we are prioritizing. My main takeaway, I would say, is that and going back to the talk I gave earlier, really the more voices that are involved in building this technology, the better it will be for the world. So whether it is about how, from the actual development of that, but also about what we prioritize about what is really important, what skill sets are we really trying to replace with this technology, and how to use that in real-world scenarios, in interaction with human beings. How much of that decision is only made by maybe a few people versus getting more people involved and getting more perspectives involved. And that is something that I think the latter would really help for a positive impact of this technology in the world.
Thank you so much. I'm also calling back to the stage Gita Kutiniok for her ideas and final thoughts on what we've been discussing. Please, thank you.
Yeah, thank you very much. I mean, for me, it was a really exciting discussion, so thanks a lot. And I think it also showed that really you need this interdisciplinarity to capture AI in its whole. So I think most agreed that we are at the early stage of AI. We see still also many problems, reliability, causality, reasoning, and so on, but it's very difficult now to predict the future. For me, it's always like a door which you have slightly opened, you see already the light, but you don't really know what's behind it. I found it very interesting what was discussed also, for instance, about humanity. It's not really clear how humanity will evolve, and also from my perspective, maybe to which extent we might even fuse to a certain extent with AI. So I once gave a talk, and an 80-year-old lady then asked me, well, I mean, with ChatGPT, maybe in 10 years we have all a chip in our brain, and so the thoughts of ChatGPT and ours are merged, and I found this very fascinating. So I think this is one key question, I mean, what humanity will mean. The other, I think, what is really important and what was also mentioned is control, boundaries. So right now also with fake news and so on. So I think that is an extremely important point, that we don't lose control of AI, since it has this, as it was discussed, this enormous amounts of data. And when it gets more skills, we really need to keep it under control. And that relates also to what was said in the final phase with companies. Yeah? So all of this AI is mostly developed by companies, which certainly have their own KPIs. Yeah? So they would like to make money, that's clear. I mean, that's also their task to a certain extent, but I mean, they might not really take that much care of the human values we aim for. And so universities can do that as a neutral place, but also, as it was discussed, universities don't have enough money, I guess here, but also in Germany, I think in all of Europe, universities cannot keep up, and I think this is a key point for the future. I don't have a solution for that, but I mean, what I would also like to mention in the end is, again, I mean, digital sovereignty. I think that's something which is very important for us in Europe in general, I mean, so that we don't always have to rely on, let's say, products by the US, by China. I think that's something which we have to keep in mind. If we really want to develop AI according to our human or our European values, we have to do it here, actually in Europe. And I think also we have to act now. Yeah, so I mean, I think that the time is now to really increase the pace, increase also the investments, and if we really want to keep, let's say, human values, and that ensure that so that we, as the title says, the humans in the age of AI can really still, I mean, live as a human and live also with AI in that sense. So, and also one last thing I would like to mention, which is always dear to my heart, which I think would be also very advantageous for the future, if we could develop a labeling system for AI. So if someone buys an AI system, that people know exactly how much energy it uses, how trustworthy it is, how explainable. So maybe like if you buy a refrigerator, you have, I'm sure also in Portugal, in Germany, we have that these energy labels. If you have that for AI, and that could be done worldwide. So I think that would be my hope. And then, I mean, you know exactly what to do if you buy an AI system, how you can trust it, to which extent it obeys European values. And so that would be also my hope for the future. And yeah, so thanks again. I mean, it was very exciting for me to listen to the discussion.
Thank you so much, Gita Kutiniok. I'm not sure if Mr. Elon Musk would appreciate those labels or some of the Americans that are really developing AI. But thank you so much. And thank you so much also to every one of you for having been discussing all these matters with us. Thank you.
All right. Thank you.
Okay. Thank you once again. So we're about to come nearing the end of another edition of INESC TEC Autumn Forum. For the closing session of the event, I'm now going to call to the stage the Minister of Education, Science and Innovation of the Portuguese government, Fernando Alexandre. Please do come to the stage, Mr. Minister.
Good afternoon. Thank you for inviting me to be in this celebration of INESC TEC for 40 years old. So I would start by congratulating the founders, all the directors, including the current João Claro, and all the community of INESC TEC for all the achievements in these four decades. I will start my talk by emphasizing the increasing importance of higher education institutions and institutions of our scientific and technological system. So we live in a world that is more complex as a result of globalization, an increasing trade, increasing financial interdependence across nations, migrations. Countries have become more interdependent, and in the last 20 years, as is shown in this figure that is built by Stanford economist Nicholas Bloom and his team, he built since 2018 a World Uncertainty Index by joining information from the Economist. It shows that the world has been hit by several shocks that have become more frequent and more extreme. So you have a diversity of shocks that are visible in that figure since the beginning of 2000s. So pandemics, extreme weather events, wars, financial crisis, and in the last 2 years or so, you can see that we had a peak, a historical peak for the time span that is considered in this figure, that is also linked to geopolitical changes. So, in this context, it is more difficult to understand the world. So events have become more complex, and this complexity has been magnified by the acceleration of technological change. So it's even more difficult to predict the future, as was mentioned just in the former panel. To predict the future is something that we know that is impossible. Karl Popper, in The Logic of Scientific Discovery in the 1950s, showed why is that. So progress depends on knowledge, and today we don't know what we are going to know in the future, so it's just a logic conclusion that we cannot predict the future. But in fact, to predict the future in this context of increasing uncertainty has become even more difficult. It doesn't mean that we don't have to try to understand the world. So the world is more complex, and the role of universities, and I was saying the role of entities of our scientific and technological system in this context becomes even more important. So to understand most of the phenomena that affects the daily life of citizens, we need to invest more. We need to have people that are more qualified, and we need to invest more in science. We need to invest more in research. But to do that, we need to show to society that it is worth to invest in research and to invest in innovation. And why is that? Because nowadays we live in a world where it is easy to sell simple solutions. So you know that there are several movements, even political movements that we call populism, that goes that way. So they try to convince people that for complex problems, you may find simple solutions. It's possible that we have simple solutions for complex problems, but it's quite complex to find a simple solution for a complex problem. So we need to invest more in the education of people, we need to invest more in science, and we need to get the acknowledgement of society that is worth to invest in science. And for society to acknowledge the relevance of investing in education and of investing in science, it is crucial that society, that people they can feel the benefits of the results of science, of the results of innovation. So one message that I would like to leave is that education is more important, the investment in science is more important, but we must be able to communicate better the results of what we do in science and innovation for societies to support the increasing investment that we need to have in education and science to face the higher complexity of our world. The second point that I would like to make in this presentation, in this talk, is that education and science are forward-looking. We live in a world of increasing uncertainty, but education, by definition, is forward-looking. So we prepare people for the future. Science investigates, it's research, it's investigating, trying to find new results that will have an impact in the future, that will bring answers to difficult questions sometime. So we need to be forward-looking. And in this context of increasing uncertainty, namely in a time where we have very fast technological changes, we have to look at what type of education we are offering to our students, what are the type of qualifications that we are offering to our students, either they are young or they are adults. When we look at the future of jobs and how jobs are going to be impacted by several changes that we are facing currently, from geopolitical to climate change, green transition, the digital revolution, all that, a survey from the World Economic Forum identifies that technological change, and namely artificial intelligence, is the main driver of changes in the demand for competencies in the labor market. So if you look at all the top fastest growing jobs, they are all linked to digital transition and very related to the artificial intelligence revolution, okay? When another Mario, okay, we already had two, so another one, the report from Mario Draghi shows that we have a mismatch, so Europe faces a lot of challenges in terms of its competitiveness and in its ability to answer a lot of challenges that the European Union is facing. And concerning human capital, there is a mismatch, a significant mismatch between what companies look for in terms of competencies and what is available in the labor market. And if you look at this figure, you see that Portugal is on the top of the mismatch. Okay, so what that means is that mismatch is that we are not synchronized, we never are, but we should try to be, not in the present, but in a near future, we should try to align what are the needs of our society, what are the needs of our economy, and what our higher education system is doing in terms of the supply of skills. And Portugal has this mismatch that is very, very significant. This mismatch is even more important in Portugal because we are undergoing a structural change in our economy. At least we all expect that we are going through that structural change. So we are changing from an economy that was mainly based on low skills to an economy that is based on a high-skilled workforce, that is based on innovation, that is based on new services and products that are really research-based. And this change to an economy that I called a new paradigm, that is the created-in paradigm, makes the role of the education system even more challenging, because once you are changing the structure of the economy, you have to have a higher education system, an education system as a whole, that looks to the future, but it's not easy to see what type of economy we are going to have in 5 or 10 years. But you have to try to find this match between what we are doing in the education system and what the economy that we want to have in Portugal will need in the context of this new paradigm. This new paradigm is crucial because if we don't change to this paradigm, we won't have high productivity and we won't have high wages. Okay? It's impossible to have an economy that is mainly based on low-skilled jobs and to have high wages. It's not possible. So to do that change, we have to try to improve the forecasts of skills in the future and to adjust the higher education system and the whole education system to that change. Also, in our scientific system, we have to be forward. Science is forward-looking by definition, okay? And education, I like to believe that is also forward-looking. But the mismatch that we have in education, we also have some mismatch in science and innovation. So if you look at some indicators for our scientific system, so we started from a very incipient scientific system in the 80s, and we made a quite successful path since then. And in some indicators, we even managed to be above the average of the European Union. And it's important to say that we don't have many indicators where we perform better than the average of the European Union, okay? So I would say that that is quite an achievement, because to build a scientific system almost from nothing, okay, we had something, but it was very, very small, very, very incipient. It was quite an achievement for the Portuguese society. But when you look at what society expects from the scientific system, it's not what we naturally expect from the scientific system, but that is what society expects from the scientific system. And I go to the beginning of my talk, because for us to increase the investment in science, we have to have the acknowledgement of society, okay? It's very easy to divert funds from science to other hands, okay? It's very easy. There are a lot of hands that are very easy to show that they benefit society immediately, okay? It's very easy. So to have this focus on increasing investment in science, we have to show that it is worth to invest in science. And for that to be a virtuous circle, you have to be able to translate the results of science into innovation. And innovation is just to have new ideas, new products, answers to the challenges that society faces. That is innovation. That is the best definition of innovation that I know, okay? Innovation is to find solutions for the problems of people, for the problems of societies. That is innovation, okay? So this ministry is named Education, Science and Innovation, okay? And it had a purpose. It was to convey the message that we need to invest in people, we need to invest in science to improve the life of people, to answer the challenges of society, okay? It was not a bundle of words, it was on purpose, okay? Education, science, and innovation. So we still have to improve the way we translate scientific results into innovation, and in the end, productivity is, you can measure it in different ways, but productivity is an interesting measure that you should never ignore, okay? Because it just measures the ability to transform value from a unit of work, okay? So if you can make and to translate value and to create value, you need to have good solutions, okay? If someone goes to his job and if he does always the same, his productivity will be always the same, okay? You only improve productivity when you go to your job and you can do things differently, you can innovate, you can find new solutions, okay? And for the country as a whole to converge to the higher per capita income levels, you have to make this change in the paradigm of our society. That is, we need to go to our jobs and do it better than we did it previously. And that is an attitude, okay? It also related with education and science. And so that is something that is the third part of my talk, that is the role of institutions, okay? So in Portugal, we don't care much about institutions. And these institutions are the set of rules, the set of incentives that move the agents. So Portuguese are very risk-averse, okay? We don't like change. Well, nobody likes change, of course, okay? Unless it is for the better. But when you have to bet if it is for the better or for the worse, well, Portuguese usually prefer to stay in the same place, okay? That's what it means to be risk-averse, okay? And so we don't change institutions. And it is not possible to improve our societies without changing institutions, okay? That is something that the Nobel Prizes in economics from this year have showed in excellent books. One of them was my professor in my PhD in London, Philippe Aguillon. You really have to care about institutions. You cannot ignore institutions, okay? And in Portugal, in higher education, science and innovation, we have ignored institutions for decades. We have the same institutions for decades. And you could say, they are great, why should we change them? They work fine. They are great, why should we change them? Well, they are not great. They have done a good job for a while, but everybody complains about our institutions in higher education, in science, and in innovation, okay? So what we are doing, we are changing all the institutions from the basic education, secondary, higher education, science, and innovation, okay? So this is a reform because we have to adapt our set of rules. We have to adapt, we have to change the incentives for the agents, because people react to incentives. And if you want to get something different, you have to give different incentives from the ones that we have currently. So these are a part of just focus on higher education, science and innovation, okay? We are also doing a bunch of reforms in basic and secondary education, but the message is that for reforms to work, you have to look at institutions as a whole. In Portugal, we like to change a bit in one set of legislation, and then 2 years later, change another bit in a set of the legislation. And then what we have is a patchwork of legislation that is really hard to read. Okay? It's really hard to read. To be polite about the previous legislators. Okay? I have a lot of stories about this. Okay? I'm always taking notes. Okay? Always taking notes. I will write a great book after this experience. Okay? It's amazing, the stories that I have. The stories that I have are amazing. Okay? Some of them, you have to live through them to believe that it's real. So we really have to change, and you have to change it looking at it as a whole, because otherwise it won't work. Because usually what you have, okay, I like this bit, just do this bit. But then another one likes another bit on another piece of legislation. And that won't work because you don't change the structure. You have to change the structure and to make it coherent. Okay? So concerning science and innovation, the aim, the goal is to have better science, to have more investment in science, but for that, as I tried to make my point more than once in this intervention, you have to have impact. People have to feel that it's worth to invest in science, because otherwise, people won't support you, and I don't know many ministers that will be able or will choose to put more money in science, okay? Because what a policymaker do is to make choices, okay? I have a budget and I decide where I put the money, okay? So, and to put more money in science, we have to have more impact. And the main reform that we are doing that is really a paradigm shift in science and innovation, and that is crucial, is to have a multi-annual framework for science and innovation. It's a 5-year multi-annual program that we are going to have. Okay, so there is a lot of uncertainty, but to face uncertainty and to get results in this very complex world, you don't get it looking at science and innovation yearly. You have to look at the medium and long term, okay? And that is also very difficult in Portugal, okay? So we have been governing our scientific and innovation system on a yearly basis, okay? And in some areas we have some strategic plans, but the country as a whole does not have a plan. Well, if I want to increase the budget of science because I want to put more money in science because I need more science, better science to face the complex world that we live in, I have to have a plan. And that is also a novelty in Portugal. Portuguese people are not used to plan at the medium and long term. Of course, every household does that. Every firm does that. I believe most of universities do that. But the state does not do that. How come that is possible? Every household plan, but the state does not plan. And that is the main change of our proposal. So we have to define the goals. You see, if instead of having a yearly budget, I'm going to have a 5-year budget, I have to have a plan. You understand that? And what is a plan? A plan is to decide where are we going to put the money? What are the priorities of the country? And instead of doing what we have been doing, that is, what is the plan for next year, is what we have been doing this year. And this year, what have we been doing? What we did last year. Okay, it's a backward, it's not a forward-looking policy, it's a backward-looking policy. It's a backward-looking policy. Okay, so we need a forward-looking policy because it's the only way, it's the only way in a very complex world where uncertainty is increasing, instead of planning less, we need more planning. And to do more planning, we have to discuss, we have to reflect, and then we will have to do our choices. And that will be difficult, I'm sure. My life would be much easier if I was here just doing what I... So the budget for next year is almost the same than the budget of 2025, and going backward, just the same, okay? My life would be much easier, but I would not change anything. I would not change anything. I wouldn't be able to reinforce the budget of science, and investment in science wouldn't have much bigger impact in society and in the economy, because we would keep doing things just the same way we have been doing in the last decades. So, just to finish, my message is that the world where we live is much more complex than it was 10 years ago, 20 years ago, 30 years ago. We have more uncertainty. There are a lot of variables that show that. The world is much more uncertain than it was like 10 years ago, 20 years ago. But to face this complexity and uncertainty, we need to plan. We need to plan. We need to be forward-looking, both in education and in science and innovation. Because education, science and innovation is all about the future. Thank you.
Thank you, Minister. And that's basically a wrap. We are now concluding another edition of the INESC TEC Autumn Forum. Thank you for your presence. Now, we would like to invite you to enjoy a glass of port just outside the auditorium. Thank you so much. See you next year.